Welcome to Building Your Own AI Lab. My name is Omar Santos. In this course, we will go over the exciting world of creating your own AI lab at home or in the cloud. You can also create hybrid environments. So this course will give you the knowledge and the skills to build a very flexible, high-performance AI setup so you can learn the technology and also build modern applications. Throughout this journey, we will explore essential technologies and tools, and we'll even discuss things like cost management and security. We will also tackle advanced topics like edge computing and fine-tuning frameworks. By the end of this course, you will have the confidence to set up and run AI models efficiently, cost-effectively, and enabling you to innovate and experiment like never before. Since we will spend a little bit of time together, I would like to introduce myself. I'm a distinguished engineer at Cisco focusing on AI security. I have been in the cybersecurity industry for more than 20 years, and I lead a few different industry efforts. I am the co-chair of the Coalition of Secure AI, alongside of Google, OpenAI, Anthropic, NVIDIA, and many other companies. I'm also the founder and the co-chair of two cybersecurity standards efforts. One is called OpenEOX, and the other one is the Common Security Advisory Framework. I also serve on the board of Oasis, which is a very popular standards organization, and I'm also the author of over 20 books and many video courses. Well, enough about me. Let's get started on building your AI lab. Welcome to Lesson 1, Introduction to AI Labs and Sandboxes. In this lesson, we will start with an overview of AI labs and sandboxes, whether you're creating an AI lab at home or in the cloud. We will go over topics such as choosing the right hardware, so that means your GPUs, your CPUs, memory, and other system components. We will go over building or buying pre-built systems, and also what operating systems to choose, whether it's Linux, macOS, or Windows. We will go over the essential software for your AI experimentations, especially things like Python, Anaconda, Jupyter Notebooks, and many other frameworks. We will go over and introduce Hugging Face, Ollama. We will install Ollama to run AI models at home. And then we will go over many different Ollama integrations that you can use nowadays. We will explore the Ollama REST API and how to even use retrieval augmented generation pipelines in your lab at home and, of course, in the cloud as well. We will also explore tools like Rackflow. Let's get started. Since AI or artificial intelligence continues to advance, many organizations are asking their employees to do something with AI, to create some type of AI application and so on. Also, individuals would like to, upskill themselves and then, of course, increasingly leverage AI labs and sandboxes to experiment, to develop, and also to test any type of AI application or AI solutions before you put them into production. So these AI, quote unquote, AI labs or environments definitely provide some control spaces for you to test and learn, but they can also be implemented in two different ways. One, of course, at your home, so on-premise, and I'm going to give you throughout the course a lot of different guidance to how to implement this in your own home, right, or on-premise. And also you can take advantage of the cloud. There's a hybrid approach on where most organizations and most individuals are taking advantage of, which is basically including the integration of home-based labs or on-premise labs with cloud-based labs as well, so in a hybrid environment. So throughout the course, you're going to be learning a lot about how these environments are designed for developing and testing and deploying AI models. And they often include, of course, different types of hardware, software, and different tools that are needed to experiment with machine learning algorithms, generative AI models, and so on. You're going to be learning about tools like Ollama, the different types of hardware that you need for creating a home-based lab, and especially if you want to just take advantage of smaller language models that can now be run pretty much everywhere. And that is actually the concept of edge AI, basically running AI models at the edge, right? So at smaller environments, even in your laptop, right? And we're also going to be discussing the pros and cons of building or buying pre-built systems, and the essential software that you need to have in those systems, as well as the operating system and many different libraries that you can implement to develop an AI application. Now, one of the advantages that you have whenever you're creating home-based labs is having full control of complete oversight of your infrastructure, your data, your processes, and so on. And of course, convenient, right? You're not paying cloud provider or another provider for any type of infrastructure or for inference for that matter, even though inference costs and infrastructure costs are getting a little bit better, but it's still not cheap nowadays. Another advantage is that, of course, sensitive data will remain within the organization or within your premises and reduces the likelihood for some type of compliance problems or for you to worry about the provider actually, using that data for retraining their models and so on. Even though most of the foundation model providers, including OpenAI and Anthropic, they provide capabilities or even, legal features that basically guarantee that they will not use your data for training their model. So there's different options nowadays that you can take advantage from these foundation model providers, and especially in the enterprise version of it. Now, we talked about the advantages of home-based labs. There are a few challenges, right? So you do have to invest in the infrastructure. We're going to talk about building or buying pre-built systems, choosing the right hardware later in the course. But it doesn't also come cheap, right? It requires some initial capital for your GPUs, for your software licenses, and many other things. Even though you can take advantage of a lot of open source packages and libraries nowadays for developing AI applications. As a matter of fact, the majority of them are open source. Everything that I'm going to be including in this training is around free open source software. Another challenge with a home-based lab or on-premise lab is that you have to patch. But you also have to patch in the cloud. But this one, you actually have to keep up with regular updates for all your environment, your hardware, your software, your operating system, and so on. So, of course, in the cloud, that depending on the cloud provider, depending on the cloud model that you are using, that there's a shared responsibility in there, right? Small organizations may also lack the expertise. So if you're thinking about doing this for your company, and if you're in a small company, you may have the challenge that your peers, your coworkers may lack the expertise or at the end of the day, the budget to maintain cutting edge labs as well. Now, later, we're going to go over cloud-based AI labs and sandboxes and how to set up platforms like AWS. So in AWS, you have SageMaker, Bedrock. In Google Cloud, you have Google Vertex AI. Azure and Microsoft provide a lot of AI capabilities as well. Pretty much all the service providers nowadays provide some pretty robust capabilities to deploy AI applications. And we're going to learn about the pay-as-you-go pricing and also, how to do hybrid integration. So in many organizations and in many use cases, you're going to have a permutation of both. So a home-based lab or an on-premise lab and a deployment in the cloud. Perhaps, some of your data is at home and you do some of the processing in there, and some of the more elaborate functions for reasoning and many other things may be in the cloud, right? So it all varies depending on the use case and depending on the implementation. In the next section, we're going to talk about choosing the right hardware, your GPUs, your CPUs, your memory, and so on. In this section, we'll go over one of the most crucial decisions that you will make whenever you're building your lab, and that is choosing the right hardware components for your home AI infrastructure. So let's start with the backbone of any AI lab, and that is the GPUs, right? So the GPUs, or the graphical processing units, they are definitely the workhorse of any machine learning environment, right? So they're capable of performing thousands of parallel calculations simultaneously. So whenever you're selecting GPUs, you want to consider a few factors. The first thing is the compute capacity, which is measured in CUDA cores for NVIDIA cards or stream processors for AMD. And then the second is memory bandwidth and capacity, which is crucial for handling large neural networks and large LLMs. And then third, of course, is your budget, because top tier GPUs can range from just a few thousands to a few tens of thousands of dollars. So in my case, as you see in the screen, I basically selected I'm using two different GeForce RTX NVIDIA 4090 systems for this system that I'm going to be using here today. But as you know, with technology progresses so fast nowadays that I can assure you that by the time that you're watching this video, they're probably a lot more cost effective, I will say, or budget friendly and faster GPUs, right? Now, in my case, for this system, I also selected an AMD Ryzen. So let's move on to CPUs. While they are not the star performers in any AI workload, they're still essential for data preprocessing and orchestration. So look for processors with high core counts and strong single-thread performance. The latest AMD or Intel processor are excellent choice. You can go up to many cores. In my case, of course, I'm just using the Ryzen AMD chips for this system. Now let's talk about memory or RAM. For RAM, the rule is pretty simple. The more, the better. So I would say start with at least 64 gigs of RAM for very small projects, but plan for 128 gigs or more if you're actually working with very large language models or computer vision applications. In my case, what I have in here is DDR5 memory, and I think that I have 196 gigs of RAM, 192 gigs of RAM or so. Later, we're going to go over and log into the system, and you will actually see the memory and the GPUs running. Now, for storage, you want a tiered approach. You configure your systems with fast NVMe SSDs for your operating systems and active databases and datasets as well that you will use. The large capacity SSDs for your model storage may be a good choice. And you can also use traditional hard drives for archival or backup purposes. Networking is often overlooked, but is crucial for many reasons, right? Consider investing in high-speed networking infrastructure. In my case, I have that ProArt motherboard that actually has a 10 gig Ethernet. And in many cases, actually, you want to either have it within the motherboard itself, or you can just buy an external network interface or NIC for you to actually use within your system. Another thing, of course, is cooling. So cooling is critical but underestimated in many cases. So whenever you're running multiple GPUs, whenever you're running CPUs, you definitely have to actually consider your cooling solution, and those environments need to be robust. So I'm using liquid cooling for CPUs in here, and the other thing is you make sure that you have a case or a chassis with adequate airflow. So and also of course proper ambient temperature in your server room or in the room that you're going to be running your system. So again, for those of you that are building a system on a budget, you probably want to consider to have a few of these components. Now, this system, of course, is not going to be cheap by any means, but definitely with models now becoming better and the quantization techniques become better, the compression techniques becoming better, these smaller language models can now run even on a Mac, right, or on smaller systems than mine in here. But again, this is actually one. I have two systems that are relatively similar, and it's because I want to experiment and I like to always test the latest models without having any hassle in here. Of course, in many cases, it's an overkill, and you can use the cloud, and you can host those in opinionated cloud environments like RunPod and many others. But in my case, actually, I do want to use some of my own data and run those models locally. Of course, we're going to be going over later into AWS Bedrock, Google Vertex, Azure AI Studio, and so on, where you can also use those environments, probably in a little bit more cost-effective environment if you just want to learn about a specific model. But if you're thinking about running local databases, local data sets, your own data, and so on in a local environment, definitely you can build a system that will handle most entry-level to intermediate AI workloads effectively. Technology is advancing at a very rapid pace, as we know, and we have witnessed in the last few years. So NVIDIA is always putting newer hardware and new solutions out there, along with many other companies. As a matter of fact, there's a lot of movement nowadays to move away even from GPUs to other platforms like ASICs that are going to be specifically designed for AI models and AI architectures. However, what you see in front of the screen is an example of NVIDIA's RTX power workstations, and they even have laptops. They also have a set of smaller devices that can definitely be run in your desk with Blackwell GPUs. This is something that they call Project Digits, and basically it has a pre-installed 128 gigs of RAM, and of course a Blackwell GPU in there that has 1 petaflop, which is pretty impressive for this environment. It also has 4 terabytes of SSD, so it is a pretty powerful, I would call it a small personal PC, tailored for AI models and AI implementations. You already have the 5000 series of the RTX GPUs and new evolutions of Blackwell that are continuously being introduced in the market almost on a weekly basis nowadays. It's insane how technology is basically being democratized. It's democratizing access to high-performance AI tools and AI components for you to develop your own applications. As a matter of fact, you have a plethora of open-weight models, including the ones that NVIDIA released specifically for robotics and for things like self-driving cars. And a perfect example of that is a model called Cosmos, right? Or a series of models called Cosmos as well. So definitely, this is something that you're going to be seeing some advancements in robotics, in autonomous systems. And of course, this promises a very broad future ahead of us, and also a lot of security considerations that we have to now take with these autonomous systems. But however, going back to building a lab in here, you have many different options, whether it's buying a pre-built system like this or just making something really simple. One of my recommendations is to get started. Even if you have a laptop with Apple Silicon or the M series chips, you can very easily install things like Ollama. It run a lot of open weight and open source models. And as a matter of fact, later in this course, you're going to be learning about Ollama, different things that you can integrate with your personal PCs and desktop machines and laptops, and then have a hybrid approach where you're combining a home lab and cloud resources as well. So we're going to be covering all that later in the course. Now we're tackling a fundamental question that everybody asks themselves, and that is that should you build your own system or invest in a pre-built solution? So let's start with pre-built systems, right? There are many companies out there that offer workstations, desktops, and servers that are specifically designed for AI workloads. These systems come with many different advantages. First, they're tested and validated. The components are guaranteed to work together, and the systems, in some cases, are benchmarked for machine learning tasks. And there's a few companies that are now starting to specialize just in AI systems. Now, the challenge with that is that they are very, very expensive, right? Now, the other thing is pre-built systems do have a few additional drawbacks. Typically, they come with a premium. Of course, you pay a lot more than building your own system in many cases, and you're also limited to the configurations they offer, which may not perfectly match your need. Specifically, again, you are the owner of that lab, you're the owner of the scope, you're the one that actually wants to know what type of models you're going to be running, what type of learning you're going to be doing, or what type of things you're going to be putting, quote unquote, in production within your home environment, right? At the end of the day, in some cases, it's not so much of just learning, but also taking advantage of these newer models that can automate a lot of things, within your environment, right? Now, let's explore the DIY approach, which is building your systems from scratch. We just went over, a few notes related to hardware and what type of hardware you should be using, right? But one of the most obvious advantages in building your own system is, of course, cost savings, right? By introducing components directly, you can often build an equivalent system, or even better, for significantly less money. You also gain complete control over every single component choice and allows you to optimize your specific workloads. Now, building your own system also provides a really good knowledge, right? That you will understand your hardware intimately, making troubleshooting and upgrades easier, down the line. Plus, you can customize aspects like the cooling solutions, cable management, of course, the GPUs, the CPUs, the memory, and so on. But building isn't without any challenges. You need to research component compatibility, handle system integration, yourself, manage multiple warranty claims if issues arise, and of course, tackle your own troubleshooting. There are some other specific scenarios where each approach will shine, right? The pre-built systems make sense whenever you need systems up and running very quickly. You don't have any, worry about about the cost, and you have limited technical expertise in-house to actually build a system, right? Now, build your own is often better whenever you're working on a tight budget or you need highly specific configurations and you actually have the technical expertise available. And at the end of the day, if you build any other PC for gaming and so on, it's basically exactly the same approach in here. In the next section, we're going to go over a few tips on choosing the operating system, whether you're going to be running this on Linux, Windows, or Mac OS. Now we're going into another decision that you have to make, which is choosing the right operating system for your AI development environment. So let's start with the most popular choice among the AI community, which is Linux. I personally use Linux at home in this system that you see in here, and many others, including many clusters running Proxmox and other environments for building labs for ethical hacking, for incident response, and so on, since I am mostly concentrated in cybersecurity. However, for my AI lab, definitely my choice is Linux. First, it's open source. It's definitely customizable. There are tons and tons of libraries for Linux that are related to machine learning and AI nowadays, and it allows you to optimize your system for specific workloads. The other thing is most AI frameworks and tools are developed within Linux in mind, and this makes it the first platform to receive updates and new features in many cases. For the Linux distribution, I am just running Debian. You can run Ubuntu and many other flavors out there, but I'm just running Debian to make it simple. Now, you can also, of course, use Windows. It is not the traditional choice for AI development. However, Windows has made many different strides with Windows subsystem for Linux or WSL2, right? This gives you access to a full Linux environment within the Windows native support. And also they have native GPU support for deep learning and many different integrations with other Windows tools. Now, Windows makes sense whenever you need to use Windows-specific software. Your team may be already familiar with the Windows ecosystem. And at the end of the day, most of the environments here, they actually run on top of Python, like libraries like Llama Index, LangChain, LangGraph, Langsmith, many others. Llama is another one that you're going to be learning later here today. So definitely, a lot of things are platform independent. Now, moving into Mac OS, I am actually running a Mac in here, and I'm SSH to that Linux system. So typically, my operating system for daily use is Mac OS, but I use that, of course, to connect to Linux systems within my environment here at my house. However, those systems nowadays with the M chips, so M1, M2, M3, M4 chips, they definitely offer better support for AI frameworks. And there's a lot of growing support for AI frameworks that are optimized for Apple Silicon. However, macOS has limitations for your AI workload. For example, you have limited GPU options, right? So you're restricted to Apple's integrated solutions. There are few deployment options in production environments and potential compatibility issues in some specialized AI tools. Now, my practical recommendation for most AI labs is to use Linux as your primary development and training platform. Again, Ubuntu, Debian, many other flavors of Linux are definitely a really good starting point. They also often offer wide community support and many different workloads and tools and related tools that are stable for those environments as well. In the next section, we're going to go over some basic or essential software to run, like Python, Anaconda, Jupyter Notebooks, and other frameworks. Let's go over some key tools and frameworks that are foundational in the world of AI. The first one is Python. Python is the bedrock of AI development. It has emerged as the de facto programming language for AI development because it's simple, and due to its simplicity, readability and extensive ecosystem, you actually have a ton of libraries. And these libraries definitely facilitate tons of AI tasks, from data manipulation to complex neural network construction. A few notable libraries that not only assist now because of generative AI, but have existed for quite some time, especially for numerical operations and data analysis, is NumPy. And NumPy, of course, is for numerical operations, Pandas for data analysis, Matplotlib, and Seaborn for visualization. And then, of course, for machine learning and deep learning, libraries like TensorFlow, PyTorch, and Keras were widely used and continue to be widely used. Additionally, Hugging Face Transformers library provides a lot of tools for working with large language models, which are very, very crucial for generative AI applications nowadays. Now, another comprehensive distribution of a Python library or ecosystem that is not only for Python, but also for R, is called Anaconda. And Anaconda is basically specifically for data science and AI applications. It simplifies the package management and deployment, ensuring that you have a consistent and controlled environment for your projects. Anaconda comes with a powerful package manager that handles library dependencies and versioning, and then allows you to create isolated environments for different projects. And this isolation ensures that changes in one environment do not affect others, and then provides you with stability across your workflows. Another tool is Jupyter Notebooks. And nowadays, with Google Colab, it makes it even easier for you to exchange, example code. And then, of course, this tool is invaluable for data exploration and visualization and iterative development, right? So Jupyter Notebooks offer an interactive web-based environment where you can combine code and the execution of code with rich text, mathematics, plots, and media. And Jupyter Notebooks allow you to document your thought process alongside your code. Now, beyond Python, Anaconda, and Jupyter, there are several other frameworks and tools that are essential for building a robust AI lab and, of course, building an environment for you to experiment. Another one is called Kubeflow, and it's an open source platform that is designed to facilitate machine learning workflows on top of Kubernetes. So Kubeflow allows you to develop, to orchestrate, deploy, and run scalable and portable machine learning and AI workloads, and of course makes it easy for you to manage complex models and experiment. Another one is, of course, Hugging Face, the hub for open source or open weight AI models and tools. And particularly, it is known for its Transformers library. So it provides a lot of pre-trained models for natural language processing tasks and many other implementations. Now, later in the course, we will talk about a lot of libraries like LangChain, LangGraph, which is part of the LangChain ecosystem, Llama Index, or Llama to run open weight models locally within your environment, vector databases like ChromaDB, pgvector, Weaviate, Pinecone, MongoDB Vector, Atlas Search, and there's so many of them out there that I'm actually missing in here. So in the next segment, we will actually start covering the ecosystem of Hugging Face and additional libraries and tools that you can deploy within your lab. Now let's explore Hugging Face, a platform that has revolutionized how we develop, share, and deploy AI models. Whether you're just starting out or running a full-scale AI lab, understanding Hugging Face is essential in today's landscape. Let's start with the basics. What is Hugging Face, right? So think about it as the GitHub of AI. It's a platform where developers and researchers can share, discover, and collaborate on AI models and also datasets. But it's much more than just a repository. It's a complete ecosystem for AI development. You have thousands and thousands of models, datasets, spaces, and spaces basically are where you can showcase different applications, right? Now, at the heart of Hugging Face is a Transformers library. Now, let's look at a practical example. Let's say you need to build a system where you want to do visual question answering. You can just browse through the models, select multimodal, and click on visual question answering, and you see a whole bunch of open weight models. And open weight means that, of course, the source of the model and the weights are completely open to the public. So let's, for example, look at any of these models in here. Let's say the open face model here. If you go into files and versions, you see that you have information about the model itself, so the README, the configuration, a JSON file for the model itself, and you also see a whole bunch of files that start with the name model and then that end with the extension safe tensors. Now, safe tensors is a secure and efficient file format designed for storing tensors, which are basically multidimensional arrays used in deep learning and machine learning models. These were developed by Hugging Face, so safe tensors were developed by Hugging Face and addresses vulnerabilities in traditional formats like Pickle. And these safe tensors basically introduce security features that ensure that files cannot execute malicious code during loading. So unlike the Pickle files, safe tensors do not allow embedded Python code and then eliminates the risk of executing harmful scripts during deserialization. Outside of security, safe tensors enable faster model loading, and also the format uses serialization and compression to reduce the file size and optimize the storage and the transfer of models as well. The other cool thing is that safe tensors can be used across many different programming languages and frameworks like Python, and is cross-platform independent, right? I wanted to actually at least introduce you to the underlying information about the models, safe tensors, Hugging Face, and so on. And we're going to be actually going over this framework and this environment throughout the course. Let's go over one of my favorite platforms to run whenever we are building an AI lab, and that is Ollama. Ollama is a free open source platform that is designed to run LLMs or SLMs, small language models, locally on personal computers, in your home machine, and in the hardware that we have been discussing here today. It simplifies the process for not only running, but also downloading and installing LLMs and SLMs without relying on cloud-based platforms or requiring extensive technical expertise or data science background. Now, Ollama supports a very large number of models, including Llama, Mistral, CodeLlama, Gemma. You see them in the screen here. And if you click on models, you will see the plethora of models that they actually support. And this list is growing on a daily basis. I mean, technology is moving so fast, and of course, these models are being introduced on a daily basis. And Ollama actually keeps up very, very, very quickly with newer models. You can also access their GitHub repository and get a lot of information about not only how to download and run Ollama and install it, and we're going to go over that in the next few minutes. However, different types of supported libraries, and of course, information about their models, as well as other information about how to create model files, how to create or copy models, and pull the model from the repositories, copy a model, and so on. There are also a lot of community integrations that we're going to visit later in the course. We're going to be going over things like Open Web UI, chatbots that you can instantiate not only in a web GUI, but also in the terminal window as well. So again, the key features of Ollama is being able to run LLMs directly on your machine, and of course, ensuring different benefits like privacy and avoiding cloud dependency and unnecessary costs in the cloud. And especially as models are becoming more accurate, and even smaller models, because of the quantization techniques and the compression techniques are enhancing on a daily basis nowadays, definitely Ollama offers a lot of benefits in here. I am running Ollama in this system. I call it Cerebro, but basically I can ask any questions. What is machine learning? And then of course you see how fast I get inference, and of course a pretty detailed overview of what is machine learning. So very, very cool platform. You're going to be learning a lot about this platform here today. In the next section, we're going to go over how to install Ollama and how to run different models. Installing Ollama is so simple. You can just download it from the ollama.com website. So they have two ways that you can download it, either here in the bottom of the screen, or of course right here on the top. However, this is available for macOS, Linux, and Windows. Since I'm running in a Mac, it defaults to macOS, and you can just download it for macOS by clicking on this button. For Windows, you can download the installation package right here. And then for Linux, you can just run this command. It's basically pulling the installation script from ollama.com and then piping that to the shell. If you go to their GitHub repository, they also have the same instructions right in their README. So for Mac OS X, they have the download link. For Windows, the same. And then, of course, the same command that you saw earlier. So the curl command. They also have installation instructions for manual install. So if you click on here, they go and walk you through the manual installation in Linux in case you want to customize a little bit of the installation as well. Now, if you go back, they also have an official Docker image in Docker Hub. So if you click on that, it will take you to Docker Hub. And you see here the Ollama Docker image. You can just do a Docker pull Ollama/Ollama and then run it within your system as well. So many different options for running and installing Ollama in an extremely simple way. Once you install Ollama, you can run the Ollama command. You can do Ollama run and then run a model, just like you're seeing in here, or pull the model with the pull command. But if you want to actually run a model, and you don't have the model installed, it will pull it automatically for you. So in this case, I can just ask, what is machine learning again? And then, of course, I'm getting inference from that model. Now, if I click or press Control D, as in David, it goes back to the terminal window. And there are many other Ollama commands in here. So if I do -H, you see the different flags and commands that are within the environment. You have Ollama serve, Ollama create to create a model from a model file, Ollama show to show information about a model, and you can also do an Ollama list, just like this, and you see all the models that I have already downloaded in this system. So I have Llama 3.2 in there, so I can very easily get information about the actual model by just doing Llama show and then Llama 3.2. And then in this case, you see the architecture, which is Llama based, of course. The number of parameters, in this case, is the 3.2 billion parameter version. The context length is 131,000, so 131K for context length. The embedded length you see in there, and the quantization techniques as well. So you may ask, what is this quantization Q4_K_M? Basically, this is a specific method that is used to reduce the memory and computational requirements for large language models. They represent their weights in lower precision, specifically in this case, 4-bit quantization. So the Q4_KM configuration is part of the K-type quantization methods that introduced in tools like, of course, Llama CPP and GGML and many others, right? So around precision and performance, basically, at the end of the day, this is actually balancing accuracy and memory efficiency. So again, the benefits in here is to have models that are memory efficient. So models quantized with a Q4KM require significantly less VRAM, like, for example, around 7 gigs for some 7 billion parameters, right? And making them suitable for running on consumer-grade GPUs or even CPUs in some cases. But I will definitely suggest for you to run this using GPUs. So again, there are several other commands, PS, for example, so you can do an Llama PS to list running models, CP for copying a model, RM for removing a model, and then you also can get the help for any of the commands or the options in here. Now, if I run the Llama PS command, you actually can see that the Omar model_32 is running, and at the end of the day, it's a copy of Llama 3.2, and you see the ID, the size, and the hard drive for the SSD in my case. The processor in this case is actually running on top of GPU, and then additional information. So once again, Llama is ideal for developers, for researchers, and any AI enthusiast who wants to leverage powerful LLMs or SLMs locally. And applications range from building an AI-powered tool to integrating LLMs into a specific software via APIs and so on. And later, we're going to see many different examples on how to leverage Llama and other tools in the ecosystem. Llama's growing community has contributed to a variety of different integrations, different tools, and frameworks that extend the capabilities of Llama across different platforms and different use cases. So in the GitHub repository for Llama, which you see in the screen, there are many different community integrations, and I would like to highlight a few. And this list is growing by the minute, by the way, but I would like to highlight a few of them in here. The first one is actually OpenWebUI. OpenWebUI is a GUI that can be run on top of Llama to run many different LLMs or SLMs, small language models. And as a matter of fact, I actually already have it installed, but you can really easily install it in your system by just doing a pip install OpenWebUI, just like you see in the screen. And then to run the WebUI, you can just do OpenWebUI serve, and then point your browser to your IP address. In this case, their example says localhost. I have it running on a separate system called Cerebro in my lab, but you will point your browser to port 8080, just like you see in the screen. I have this running already in my lab at the host called Cerebro, and you see that I'm pointing to port 8080. Just like you see in the screen in there. And basically you have a ChatGPT-like GUI, and where you can ask any questions, you can select from different models. I have an uncensored model here that I was playing with, and as a matter of fact, I'm just going to select here from the screen the pre-populated question of explain options trading, and I'm going to submit that, and as you see, you get some inference back, so the results are basically the options trading is similar to buying and selling stocks, but with some case differences, etc., etc., etc. So it is interacting with the uncensored model that I'm running on top of Llama. OpenWebUI also includes many different features that can take your implementation to the next level. So for example, you can edit the output or the inference that came in from the from the model. You can also save the output to a file. You can copy it as well, just like any other chatbot. It also has the ability for you to read aloud. It does have a very bad default voice, but you can also customize this for the text-to-speech feature, and I will show you that in a few minutes. But if you click on read aloud, again, I'm just going to show you a very quick example on how this sounds.
Options trading is similar to buying and selling stocks, but with some key differences. In options trading,
So it's definitely less than optimal there, but at least it actually does have the capability. And as a matter of fact, you can do a few tweaks in here, and you can go to the admin panel, and it does have a lot of different settings. And I'm going to share with you how to get more familiar with all the different elements of OpenWebUI, especially since they're actually adding more features almost on a monthly basis. However, you can create different users. You see that I actually have only one user in this implementation, only myself, and of course the role is admin, but you can add more users by just clicking on add user, and then you can also import multiple entries with. You can also create different users by importing them from a CSV file, just like you see in the screen. We're not going to do that right now. There are many different features on how you can do evaluations. It's basically a leaderboard based on the models that you have installed in Olama, right? So these are all the models that I have currently installed within my system. You can also do function calling. You can import functions from a file, or you can export, of course, a function from there. You can configure a lot of different things within the settings. You can change the port for the web UI. You can go over different connections to other implementations or other Olama servers. I'm running everything in the same server, which is called Cerebro here, but you can actually point it to a different server, if you will. And then, of course, you can have the different models either enable or disable on a per user basis as well. So you can also do evaluations. And what are evaluations? Well, let's actually go to the documentation of web UI. Basically, they have a really cool story on where they start the story here of meet Alex, a machine learning engineer with a mid-sized company, and Alex knows that there are numerous AI models out there, right? At the end of the day, this is a TLDR. Too many models, not all of them will fit your specific needs. So basically, you can create a leaderboard for evaluations. And Open Web UI definitely offers that evaluation system. And then you can actually use a thumbs up or thumbs down to evaluate the responses coming from those models, right? So again, if I go back to my implementation here, I can actually create an arena by selecting a model. And then I can even have visibility to public to everybody in the implementation here, or a specific group if you actually have configured any groups, but in my case, I don't. So let's change it back to private. And then in here, I actually can select a model. So I can compare Llama 3.2, there's an older model in there, and I can compare that to Omar Unsensor 2 latest. And I save on that. Oops, I forgot about that. I'm going to put test 1, 2, 3, just to be simple here. And then, of course, now you have the ability for evaluating that model. And I'll show you that in a few minutes. You can also include different documents for a retrieval-augmented generation implementation. And we're going to talk about retrieval-augmented generation a little bit later in the course, but in very short, it's actually to provide additional context to the LLM using your own documents, including enabling Google Drive in here, to then reduce the likelihood of hallucinations or giving you bad information, because, of course, all these models have been pre-trained with some datasets that may not be relevant to whatever implementation you want to do. So, for example, if you want to actually go over your documents and provide that as context to then ask questions about those documents, then you can configure that in here and even have templates for you to follow along. But again, we're going to go over retrieval augmented generation later in the course. And we're also going to learn about another implementation called RagFlow. And there are many in the industry nowadays since things are actually changing so fast. But this is a really cool feature within the Open Web UI implementation here. And again, it's all free, all open source, and pretty powerful. You can even select from different embedding models. And again, later we're going to go over embedding models, how to select them, what they are, how to use them, and so on. Now, moving along, you also have the ability to do web search. And basically, in this case, you can select from different search engines, including Google, DuckDuckGo, and many others that you see in the screening here. Now, remember that I was making fun of the audio that was in the read aloud or the text-to-speech feature for reading along the output of the model. Well, you can also change the audio settings. And not only you can use the default web UI voices, but you can also use other engines, including very popular tools like 11 Labs or even Azure AI Speech and OpenAI models as well. If you select 11 Labs, of course, you have to have an API key. The same thing for OpenAI. You need an API key for you to be able to interact with it. We're not going to do that in here. Of course, this is not like a course about Open Web UI, and we have a lot of additional integrations to cover. However, what I will definitely invite you to go is to their latest documentation on where they include information about all their features. You can do function calling. You can do tool calling for creating agents within the environment, and many, many, many other customizations and different features that can take, again, this chatbot to the next level. Very, very, very impressive what they're doing with Open Web UI. Now, let's go over a few additional community integrations that I would like to highlight. And by the way, I am posting information in my blog post related to many of these integrations and many of the other capabilities that we have. We're going to talk about RagFlow a little bit later. And if you go to becomingahacker.org, you see a lot of these articles in here using AI chat CLI tool, which by the way, is one of the integrations that we're going to talk about later. And Enchanted is another one, RagFlow, and so on. And if you click on them, you actually can go over all the different implementations, examples, and how we actually have tested them, and so on. But we're going to talk about a few of them in the next few seconds. So again, the list is significantly long, and this is growing by the minute. And this is a perfect example of why technology especially in the realm of AI, is advancing at an unprecedented pace. And then given this, of course, you will expect that this list will continue to grow significantly. But I want to actually highlight a couple of other ones in here. As a matter of fact, I already opened using the AI chat tool, or CLI tool called AI Chat, as you see in the screen here. And it's one of the integrations with Olama. It's really powerful. As a matter of fact, you can do things like this. You can cat a file, so you can open a file and then pipe it to AI Chat. And then basically you can have a prompt. And in this case is a JSON file, and you're basically saying, convert that to YAML, and it actually does it for you. Or you can do AI Chat and then echo server in Node, JS. And of course, it can actually create a JavaScript for you to have a Node.js server, right? I mean, this is pretty powerful. You see another example here of translator. I translate that from, I believe, Chinese to English. And of course, you get the hello world. And apparently that's what it reads in there. I don't know Chinese, but very, very powerful. And so I have a write-up about, everything that you can do with that integration or that utility called AI Chat and how to install it. You can install it with Rust using the cargo feature set, or, the cargo package manager, or in a homebrew or Linux brew environment. You can do brew install AI Chat, and of course I have many other examples in here. Since I am in my blog, I would like to go over yet another integration that is pretty popular. And in this case, it's an open source application that is designed for the Apple ecosystem. So you have macOS, iOS, and Vision OS as well. And in this case, you can use this in combination with Olama to, of course, run language models locally and integrate across all Apple's ecosystem. I have a video that actually explains that, and it has a demonstration. I am not going to, of course, play that video, but this one specifically allows you to, or demonstrates how you can integrate with the Vision capability from Apple. So the Apple Vision Pro capabilities using models from Olama as well. So again, the list is pretty long. In the next lesson, we will explore the Olama REST API, and we're going to go over the details on how to take advantage of the application programming interface of Olama. Olama has an API that is extremely versatile, and you can access the documentation in their GitHub repository. They have plenty of different operations and methods that are available for interacting with Olama programmatically, from generating chat completions to creating a model, listing local models, and many other operations. And they have all those examples in here using a curl. So as you see, I have Olama running, and at the end of the day, I'm actually using curl to interact with the API on port 11434. And just like in the documentation, it's very well explained. You can do many different operations, as I mentioned to you earlier. And in this case, I'm actually just doing a PS to list all the models that were running at that given time. And in this case, QWQ latest is the model that was actually running. And as a matter of fact, I actually killed it right before I took this screenshot. So you can also list all the different models that are available locally in Olama by using the tags method. And I'm going to copy and paste this to my command prompt. I'm going to just type it. And you see that, of course, JSON, the very, very ugly JSON output, but this is, of course, meant to be read by a machine. It's a machine readable output, not by a human. But you see that actually you're getting information about all the different models that are installed. Of course, if I actually do an Olama ls within the environment, you actually see all the models, but programmatically, you can interact with the API for many, many different operations. Again, to do chat completions, to list all the models that are running, delete models, push models, create new ones, even create embeddings using the API. So if I scroll up and I click here in generate embeddings, you see that there is an ability or method for generating embeddings from an embedding model. So there's an example here of using all mini LM as an embedding model. And then basically the input is why is the sky blue? And of course you actually get the vector embeddings down below. So a very powerful way to interact programmatically with Olama, and many integrations, many tools that integrate with Olama, of course, take advantage of this API. Generative AI models definitely are revolutionizing pretty much everything, nowadays. And you probably already know that these models often face many limitations. And examples of those limitations are generating inaccurate information, or what we call hallucinations. So retrieval augmented generation, or RAG, is a framework that is designed to address those challenges. And basically what you do is you integrate external knowledge bases and knowledge sources, documents, and so on to the generative AI process. In other words, actually putting these as vector embeddings and then sending that as additional context with your prompt. And many other capabilities. Is not only about only documents, but you can also do function calling, tool calling, and many other techniques that we're going to go over later in the course to then provide additional context to the LLM to give you a better answer, right? So again, RAG is a technique that combines the generative capabilities of LLMs with the precision of information, retrieval systems, and you can interact with things like vector databases. So in this example that you see in the screen, basically I have my own data. And in this case, for this example, I have security best practices, security advisories, CVE, so vulnerability information, CWE, which is a root cause of the vulnerabilities, and so on. And basically, I'm using an embedding model. And then optionally, I can basically convert those documents from text or PDFs or pictures and so on into vector embedding. So in other words, convert them into numbers. And then you can put that into a vector database. And whenever a user asks a question, whether it's through a chatbot or through an agent and so on, then of course it will provide that question or that prompt. You can do semantic search and then retrieve, thus the word R or the letter R for retrieval augmented generation. And then you rank those results. There's many mechanisms to do that, and we'll cover that later in the course. And then we provide that additional context to the LLM to hopefully get you a better answer. The other cool thing is, of course, that RAG-enabled models retrieve specific authoritative information from external sources like databases, live feeds, API calls from another, or information from another application, and so on. This is also a process that we call grounding in data sciences. Basically, it uses all these processes to generate a grounded response. So if I was going to summarize on how RAG works, it basically operates in two main phases. Basically, the ingestion of documents, so the document loading, and then, of course, the storing of those documents in a vector database and so on, and then the retrieval of those documents and the semantic search, and, of course, the generation of the content, or the task that you gave the LLM or the AI model. There are many different use cases for RAG, right? You can use RAG for customer support chatbots, which are powered by different product manuals, FAQs, and support documents to provide assistance to, of course, a human in that case, or content creation. Writers can actually use RAG to generate articles. You see this a lot in the news nowadays. Healthcare, you can retrieve accurate medical documents to provide medical advice by referencing updated clinical guidelines or even patient records in some cases. In finance, you can actually do a lot of real-time insights. Basically, you can retrieve information, live information about stock prices, market trends, regulatory updates, many other things that can absolutely be provided as additional context to the LLM to give you a better answer. So that is retrieval augmented generation. Throughout the course, you're going to be seeing a lot of different tools that you can integrate within your lab and within your sandbox environment to start playing with this, including different vector databases like ChromaDB, PGVector, MongoDB has a vector search in their Atlas implementation, and Weaviate, and there are many, many others out there as well. Earlier in the course, we were covering the different OLAMA integrations and many different community efforts that have integrated with OLAMA and other implementations as well. But in this case, I kind of tabled or I postponed going over one of the integrations, which was called RAGflow. And RAGflow is an open source retrieval augmented generation. We just cover what retrieval augmented generation is, or RAG, and it's an environment, an engine that will actually integrate with OLAMA. And of course, you can run different large language models or small language models in there. It allows you to take advantage of many different features to create RAG implementations and also to create agents. So what you're seeing on the screen is a blog post that I wrote that I introduced RAGflow. And in there, I actually have links to their developer documentation, which I have open in a new tab in here for later to review. And then I also include their architectural components in here. If I wanted to summarize the architectural components, I will divide them into these categories: data ingestion and processing. So of course, accepting different data formats, including PDFs, Word documents, web pages. You can actually search the web and export that as HTML documents, and then introduce that into the knowledge base. And that's the second component, knowledge base management, which is basically data that is stored and transformed into vector embeddings and stored in vector databases. So then you can retrieve that data. And then, of course, you can have different advanced indexing and chunking methods for enhancing the retrieval accuracy from those vector databases. And all this functionality is built in within this ecosystem. And then, of course, you have the retrieval method to actually retrieve and search the knowledge base to identify the relevant information to then provide that to the actual language model. So that's the language model integration here. So to provide additional context to the language model to reduce the likelihood of hallucinations and then give you a better response. And that is the next phase. The other cool thing is that the system will actually produce answers that are also including citations. So basically providing traceability and transparency to the original data sources. And then in that case, you can provide additional citations for authoritative content that you have given the system, and then the specific sections of those documents that you created the vector embeddings from, right? So this is really, really powerful, very similar to what you see in tools like Perplexity and many, many other retrieval augmented generation implementations in the industry. The other cool thing that it actually has is a user interface and an API. So everything that is in the user interface is also in the API within their environment. Now you can deploy this locally. This is only the hardware requirements for RAGflow. Of course, for Ollama, depends on the model that you're going to be using. There are different requirements and different hardware components that you may have to invest a little bit of money. And we talked about that earlier in the course. Now, one of the easiest way to deploy RAGflow is by using Docker. And in the same write-up, I include information on how to use Docker Compose. And at the end of the day, you clone their GitHub repository. And again, all this is in the link that I'm showing here in becominghacker.org in my blog post. Once you clone the repository, you change the directory. And in that case, in here, I just perform or executed the Docker Compose command that you saw here in the screen, right? So in the write-up. Once you actually have that, you basically just navigate to the IP address of your system using your web browser, right? And in there, you can select from different model providers. Of course, in this case, we're using Ollama, but you can integrate with OpenAI, with Bedrock in AWS, Anthropic, Azure, and the list goes on and on, right? So you can run models from Hugging Face and many, many other implementations that they have. It's pretty powerful. Now, to configure an LLM, in this case, for Ollama, I'm actually using the model type of chat, and you can integrate this with embeddings. And as a matter of fact, you need an embedding model in order for you to actually convert your data and your knowledge bases into vector embeddings to then provide that information to the LLM to do something with it, right? Or to store it into a vector database so you can actually do the retrieval, right? So the R of a retrieval augmented generation, or the RAG. Now, in this case, I'm actually just using Llama 3.2 just because of convenient access to that model at the time of recording. And then I'm pasting my IP address, or I'm putting my IP address in here, 192.168.10.88 on port 11434, which is where the API for Ollama resides, right? And then in this case, you can actually put an API key. If you have locally deployed models, then you can ignore that and you're running Ollama. But if you actually have another model or another model provider, then you need an API key, for example, OpenAI and so on. But in this case, we're actually running everything locally. And basically, I'm putting 16,000 max tokens. It depends on the model, depends on the implementation, and also the compute power. The max tokens is something that you need to refer to depending on the model capacity as well, right? So Llama 3.2 has a different limitations for maximum tokens than, let's say, O1 or O3 from OpenAI. It also allows you to configure if the model supports vision, because you can integrate this with the vision capabilities of some models. In this case, I am not including a vision. Of course, you can click on OK and then move to the next step. And everything is actually documented step by step. I'm not going to read the page here for you, but I want to show you something that is extremely powerful here. And one of them is, of course, for you to do evaluations of your implementations. I basically created a knowledge base called super secret data, right? And in that case, I basically had the output of the SQL injection or SQL injection prevention cheat sheet from OWASP. I put it into a text file and I uploaded it to a knowledge base. And at the end of the day, behind the scenes, what it's doing is putting it into a vector database. Then in this section, I basically did a test for retrieval. And you can play with a lot of different metrics, including similarities, thresholds, keyword similarity weights, and many others, right? So you can also use a re-rank model if your implementation has it available. But in this case, you actually see that on the right, all the chunks of the documents that were retrieved by the implementation. Let me make this a little bit bigger so you can see. So all those are the chunks of the documents, in this case only one, that I actually uploaded here. And then that can be used as additional context for then sending the information to the LLM to get a better answer. You can also create assistants. And basically, you have the ability to create an assistant. In this case, I just call it a web application security expert. You can put a description. You can even put an avatar. And in this case, you can even set an opener. And in my case, I just put, "Hi, Omar, I am your web application security assistant. What can I do for you?" Right? So that will be what you will see in the input section for the prompt from the user, right? And you can, of course, be as creative as you want in there. You can disable to show the quote or not. And then you can even enable text-to-speech. And in my case, I'm actually selecting the knowledge base that I previously created called super secret data, right? Another cool feature of this implementation in RAGflow is that allows you to do different system prompts for, of course, your assistant. And in this case, the system prompt that I configure says that you're a web application security expert specializing in identifying and mitigating vulnerabilities within web applications. Your responsibilities include blah, 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 different vulnerabilities. So, of course, the more prescriptive that you are, the better results that you will get from the AI model. And later in the course, you're going to see many other examples of prompt engineering techniques for system prompts and assistants. In this section, you can also see that you can play with different similarity thresholds, keyword similarity weights, the number of documents or the top N for the chunks for the documents that you're going to be retrieving to then send to the LLM. Also, you can configure multi-turn optimization, selecting re-ranking models, and basically re-ranking is the technique that you can deploy within your retrieval augmented generation environment for the retrieval aspect of the semantic search. And once you get the chunks of information from a vector database or from multiple vector databases, you can re-rank those results to then send the most relevant data to the LLM to, of course, then get a better answer. Now, all these I have it documented within the write-up in here, including the top-end results, the multi-turn optimization, right? Basically, multi-turn conversations is for follow-up questions and contextual dialogue capabilities within the implementation. So all this, again, is all documented here. But one thing that I want to highlight is that you can also create AI agents. It introduces the methodology and the capability for you to create agents with very low code or no code requirements. So basically it's featuring low code, no code workflow editors, and then a graph-based task implementation. So in other words, you can create an agent. So they even have examples of different agents that you can select from. But in this case, you can basically drag and drop different types of operations, whether it's retrieving information from a database, interacting with another application using their API, and then follow-up questions, reasoning, and many others. So this is extremely powerful for anybody that is actually trying to create an agentic implementation with LLMs, and of course, integrating this with Ollama. So once again, all the links for their documentation and their detailed explanations on how to create agents in a very, very step-by-step way is all linked in my article, in my blog post. So take advantage of that. Now, in the next lesson, we're going to be going over cloud-based AI labs and sandboxes, the advantages and disadvantages of running some of these labs in the cloud. You're also going to be learning about how to deploy Ollama using Terraform in AWS and many other things. You're going to be learning also about Amazon Bedrock, SageMaker, Google Vertex AI, and Microsoft AI Studio. Welcome to Lesson 2, Cloud-Based AI Labs and Sandboxes. We start with a discussion about the advantages and disadvantages of cloud AI labs and sandbox environments. We will explore Amazon Bedrock, Amazon SageMaker, Google Vertex, and Microsoft Azure AI Studio. We will then finish with a discussion about cost management and security. Cloud-based labs or setups or sandboxes definitely can leverage many different third-party platforms that are so popular out there, like AWS, Google Cloud, and Azure. In the case of AWS, we already mentioned that they have things like Bedrock, SageMaker, and many other machine learning platforms that are available to anybody in the industry. Google Cloud, they have Google Vertex AI, which also allows you to deploy many different models, fine-tune models, and even train models from scratch and so on. Azure is another alternative, and of course they have Azure AI Studio. And at the end of the day, all of these are competing against each other, so they basically provide very similar functionality. So let's go over some of the advantages and the challenges of deploying a cloud-based AI lab or a sandbox. The first advantage is scalability. Resources can be scaled up or down on demand to meet your workload requirements. The other thing is that you have the pay-as-you-go pricing, and it eliminates upfront hardware cost, and you only have to pay for what you use. So in some cases, people go overboard at home and they buy too many PCs and too many, hardware components. And I'm pointing fingers to myself because I do that all the time. And in that case, I barely use some components that I buy, and some other ones actually I do use it every day, right? So in this case, the cloud allows you to pay as you go, and then you only pay for what you use. The other thing is that we're going to talk about the challenges. Is one of them is cost as well, because it can also bite you at the end of the day. So if you have a pretty comprehensive environment in a cloud environment, whether it's AWS, Google Cloud, or Azure, they're not cheap, right? Now, teams can also collaborate remotely from anywhere. So if you're doing this for your team at work, then you can do a lot of collaboration because everything is in the cloud, right? The other thing is providers offer pre-configured environments with very cutting-edge tools with generative AI implementations, Jupyter notebooks, many different large language models that you can choose from, and methods for evaluating your application, and many things that you don't have to actually deploy from scratch. Now, if you're learning, one of the cool things to do at home is actually to deploy some of these libraries, from scratch. We're gonna go over things like LangChain, LangGraph, many other libraries for orchestration and for you to create agents And definitely you can deploy that at home with Olama running different models, and you can practice your skills and upskill yourself. And, of course, be able to learn these cutting edge tools and libraries and implementations. But, of course, the cloud provide a lot of pre-configured environments and a lot of ways that you can just very easily just spin up a VM or deploy different containers in a very, very, very fast pace for you to experiment and to play with large language models, right? The other thing is the infrastructure, as far as the hardware management, is all handled by the cloud providers. You don't have to worry about that, right? And they are updating their hardware. And in your case, you will have to actually upgrade your system, your server, your PC, and so on. But there are definitely a lot of challenges. One of them is a data privacy concern. Now, a lot of cloud providers, they're actually very trustworthy, including AWS, Google Cloud, all the ones that I've been mentioning, of course, are the major ones. But, a lot of organizations, especially whenever it comes to AI, they are very concerned of their data being exposed to an AI model or an AI model provider for them to actually use that data for training. Many, many providers nowadays, including AWS, Google Cloud, and Azure, they actually have contractual agreements with enterprises on where they guarantee that none of the data will be used for training any type of AI model. And that's actually something that is extremely popular in the market nowadays, is actually having those contractual agreements with their providers to make sure that the data is not being exposed, right? Another challenge is vendor lock-in. In other words, switching to another provider can be difficult because of some type of proprietary tools or different configurations. And of course, at the end of the day, a lot of overhead for you to actually switch between the providers. Nowadays, it's a lot easier. We're living for the longest time in a multi-cloud environment, but there's still a little bit of a challenging if you want to actually switch providers in some cases. The other thing is the performance will rely on a stable connectivity, so latency can affect real-time application, especially if you're thinking about doing somewhat of a hybrid approach between a home-based or an on-premise lab and a cloud-based lab as well. The other thing is that even though they provide a lot of pre-configured environments, there's limited customization. So cloud solutions may not offer the same level of configuration options that you have, of course, at home. So budget, data sensitivity, scalability, and even expertise. You need to be skilled, and you may prefer home-based labs for a little bit greater control because you may not be familiar with a lot of cloud-based implementations like AWS and Bedrock and so on. And some of them, that can be a little bit convoluted as well. But this is my recommendation. I always recommend for you to do both, especially we're talking about here learning, building labs for you to learn the technologies and the different libraries, surrounding libraries that make up an AI application. So whether you're using something like LangChain, Llama Index, and so on, of course, you can deploy that whether it's in the cloud or on-premise. But for learning, it will be amazing if you can learn all three cloud providers. So AWS, and I'm generalizing in the top three, of course, the most popular ones, but Google Vertex or AI Studio in Azure or Bedrock or SageMaker, having exposure to all these environments will definitely make you a lot more marketable, and it will actually increase your knowledge, in all those platforms, right? So again, it's a personal decision, but I always recommend for you to actually do both. Deploy things on premise and your home, and also, even if it costs a little bit of money, deploy a few things in these providers. Let's go over Amazon Bedrock or AWS generative AI platform. Bedrock is a fully managed service by, of course, AWS and Amazon that allows you to deploy different types of AI models and features to accelerate your business workflows, and of course, for you to deploy different AI implementations. A few of the key features of Amazon Bedrock is that it offers a curated list of models that you can use, foundation models from top AI organizations, including Anthropic, Cohere, Stability AI, Meta, and many others, right? So even, of course, Amazon's own models. These models are, of course, pre-trained on extensive datasets, allowing you to perform different tasks, and you can combine these with other implementations in an on-premise lab to then, experiment and of course, become familiar with these technologies, right? You can come to this section here, the custom models and fine-tuning, and allows you to, of course, to fine-tune different models and create your own domain-specific model. Or you can also generate synthetic data from a large foundation model, basically using that as a federated learning environment where you can use a model for, I'm going to put here M1 for the first model, to then generate synthetic data to train a new model. I'm going to call it X in the screen here, right? So that's what the distillation techniques and functionality in Bedrock, as well as other cloud platforms, they have similar methodologies and similar features. You can, of course, do this on premise. However, the compute power for some of these may take a significant investment. So that's where you playing with these cloud platforms, it makes it a little bit more budget friendly instead of you having a bank of GPUs in your environment. The other cool thing that Bedrock actually has is that you have a playground just like the playgrounds that we were covering earlier with different implementations, including Rackflow and some other ones. But this is basically included within the environment, and you have a single prompt to generate single responses or generate a conversation and iteratively submitting prompts and replies to see his response so you can evaluate your custom application. It also allows you to create agents. So if you navigate to the agents section here, you can create an AI agent very quickly. I'm just going to put here Omar test agent 1. And then, of course, you can put a description and even enable a multi-agent collaboration. So basically, if you have more than one agent, they can collaborate and interact with each other. And then once you click on create, it will take you to this screen where you can select specific models. By default, I had Claude 3.5 Sonnet because I already had deployed it in here. But again, you can use a specific service role, create a new one, select one from the pull-down menu. I don't have anything created right now. And then you can give a specific instructions for the agent. So basically system prompts and personas, and then associate this with other functionality, including code interpreter, even selecting whether the agent can prompt for additional information from the user and so on, as well as how to perform encryption in your datasets, right? Even customize encryption settings and many enterprise-grade functionality and applications, because at the end of the day, this is, of course, being tailored for very large organizations to be able to take advantage of agentic implementations and so on. You can attach new knowledge bases, that you may actually have, or add a new one as easy as this, right? You can basically create a new knowledge base and attach that, proprietary content for you to allow the AI environment or the AI agent to provide additional context that is relevant for the domain-specific task that you want to give it. Another feature that you have is the flows feature, and flows is basically the ability for you to create a sequence of events that will correspond to invoking actions in Bedrock, and then attach knowledge bases, invoking a new or existing AWS Lambda function, and then calling Amazon Lexbot for you to interact with these applications to, of course, take your deployment to the next level. So one of my recommendations, if you're setting up an experimentation lab, I will say that start with just a simple, deployment of a model here. See how you can incorporate your knowledge bases, even if it's something that you create by copy and pasting a few, documents out there, but at least for you to get familiarized with the retrieval methods, all the different types of RAG implementations or retrieval augmented generation, and then take it to the next level into building agents, is creating creative system prompts, working on your prompt engineering tasks, and so on. And then, of course, going to the more advanced sections. But this is something that Amazon is evolving almost on a weekly basis. You see a new feature here. So again, some of these will cost money, right? Especially if you start deploying different Lambda functions, if you start playing with different data sets that will require storage and so on. But for quick labs and for learning, it is very, very minimal cost. And you can, enhance your career and enhance your skills by just playing with these feature sets in here and understanding the end-to-end generative AI workflows that exist within these cloud platforms. Let's go over Amazon SageMaker, which is basically a sister tool, if you will, or an ecosystem to Bedrock, which we just reviewed, right? So SageMaker is a fully managed service from AWS that is designed to streamline the process of building, training, and deploying machine learning models. This also allows you to deploy traditional machine learning as well as interacting with different generative AI and newer, transformer-based models as well. It has a very comprehensive set of tools and infrastructure. And as a matter of fact, what they do is they integrate a lot of the existing, very popular applications like Jupyter Labs, RStudio. They have their own canvas. They have their own code editor with a lot of additional machine learning open source frameworks like MLflow as well. So SageMaker basically is empowering data scientists and developers for accelerating their machine learning lifecycle, including these environments, right? So you have a fully managed machine learning workflow that handles all the operational aspects of machine learning development, allowing you to focus on model building rather than the infrastructure management. But one of the things that I want to highlight in here is that as soon as you're actually starting to deploy some of these features, it's also interacting with other areas of AWS, like, for example, different artifacts from experimentation and pipelines and so on, starting to instantiate different S3 buckets, EC2 instances, and so on. So you have to pay attention to the usage and, of course, the cost in here. So from a lab perspective, it is really important for you to experiment with all these platforms, right? I will not call them new platforms because SageMaker has been in existence for quite some time, but also pay attention to cost. This training is focused on generative AI applications. So I'm going to be very high level here whenever I go over the applications and the features of SageMaker, but I'm going to highlight a few things in here. So the first one, of course, you can instantiate a Jupyter Lab. You can see the different Jupyter Lab spaces. I already have one in there called test 1, 2, 3. And right now it is running on an EC2 instance. Just like I mentioned to you earlier, right? You have to pay attention to the costing here, but it's running in an EC2 instance that is the default one, that is machine learning or ML.T3 medium. And I think that it has 4 gigs of RAM and 4 virtual CPUs, right? And then you can have different image. I just selected the default one in there. I'm not going to change it in this case. And then you can launch Jupyter Lab, right? You can open Jupyter Lab in here in a different instance, and it's completely managed. Of course, you can deploy Jupyter Lab on premise, and you don't have to pay attention to cost and and different environments here in AWS. However, this makes it so easy. With a click of a button here, I have access to many different types of implementation, including PySpark, GlueSpark, a lot of Python sample notebooks, and many other capabilities in here as well. Now let's go back to the Amazon SageMaker Studio page in here. Another thing that I want to highlight, of course, you can have different compute pods and create many different pods for machine learning workflows to choose from different built-in algorithms optimized for different tasks, or bring your own custom algorithms package as Docker containers as well. And all that is definitely a feature of your environment here. And of course, bring your data sets. And Data Wrangler is a feature that allows you to prepare and do a lot of feature engineering and create different data flows to define a series of machine learning data preparation tasks and data preparation steps. So you can use a flow to combine data sets from different data sources. And as a matter of fact, let me actually open this in Canvas, and it will take a couple of seconds in here. There you go. And you can see, let me make this a little bit bigger, that you can import from tabular or CSV type of files, or even images for image classification and so on, right? You can also have different, or take advantage of different data sets. One of the things that I always highlight if you're actually just getting started with machine learning, and of course with the AI, is for you to take advantage of publicly available data sets for your experimentations, instead of using very sensitive data from either your company or your own data, right? And they provide different CSV files in here, or data, samples of data sets that you can implement for your learning, right? And then use that to learn how to train a machine learning model. You can also use SageMaker Canvas ready-to-use models to make predictions on your data without writing a single line of code or having to build a model, right? So in this section here, you can click on the ready-to-use, which is what I am already in, and then you can select from different types of models and tasks, like document queries and so on. And you see examples of document queries. This looks like a check. And of course, this is sample data and fictitious data for you to train your own model, or actually these are for readily accessible or ready-to-use models that allows you to interact with this type of data, right? So in this case, for financial applications, let's say you want to recognize different structures of financial documents, whether it's a pay stub, a check like this, and so on. It allows you to do that in a very comprehensive manner. Now, if you click here in the generative AI, let me make this a little bit bigger or smaller for you to read the generative AI. If you click on that, you can access different foundation models that are available, and also implement different retrieval augmented generation environments, including Amazon's Kendra, which is a vector database implementation in here, right? If you click on Get Started, it allows you to navigate different foundation models, of course, including Titans models from Amazon, models from Cohere, of course, Llama, and these ones are older versions of Llama, but you can search from many others and integrate a few of them from Hugging Face as well, right? Now, Kendra is a very powerful vector database that it comes built in within the environment here. But I'm going to be very brief in this example, because I want to go back to the SageMaker main dashboard, the studio in here, right? And one of the things that I would love to show you is this thing called AutoML. And AutoML is basically an autopilot for training and fine-tuning AI models, right? And if you see here, I don't have any new models, so I'm going to just create one, Omar Model 1. And now I can select from the different data sets. I'm going to select the data set from there just for very brief demonstration. And then from there, you see that it has a lot of the data preparation already done for me. Of course, I just randomly selected one data set in there without actually looking at the details. But yeah, this is a sample diabetic readmission data set that they actually had, right? So I can use data visualization to look at specific columns in here. I'm just going to go drag and drop some random data elements, and then use this data for building specific algorithms that are tailored to the analysis of, in this case, tabular data, right? So tabular data, of course, is any data sets that are organized in tables consisting of rows or observations and columns, what in machine learning we call features, right? And you have many different types of algorithms that are built in within SageMakers for tabular data and for image recognition as well. Those include things like the traditional k-nearest neighbor factorization machine learning algorithms, like GMM, and the list goes on and on, right? So we're not going to go into the details of that in this course. But if you go back to SageMaker Studio, the main page in here, you also have the ability for you to create your own experiments. And these are different MLflow experiments. And MLflow is an open source platform that is designed for you to manage different machine learning lifecycle elements. And now it's fully integrated within Amazon SageMaker. And this integration will definitely simplify the process of either tracking, managing, deploying different experiments within the ecosystem in here. And of course, not only the experience, but your models as you're training them, as you're deploying them as well. And I'm talking about both traditional machine learning models and also more modern implementations as well. Now, within the environment, you see this thing called MLflow Tracking Server. And Tracking Server is a fully managed MLflow deployment for, in this case, for you to eliminate the need to set up and maintain your own servers. But this server is where you will store metadata like parameters, metrics, artifacts for each of your training runs in a backend data store hosted within the SageMaker service. Basically, these artifacts are stored in a S3 bucket, an Amazon S3 bucket within your environment and your AWS account. So again, as soon as you actually start clicking on creating experiments and so on, there are a lot of additional components that are being instantiated within AWS. So you have to make sure that you keep track of your usage and of course your cost. Even if you were thinking about doing this in your company or in your home, this will take some significant amount of preparation and of course compute power and so on. And that's what SageMaker brings into the table, is the ability for you to do this with just a few clicks and then deploy some proven technology, including things like MLflow, to do experimentation and analysis of your workflows. But as I mentioned to you, this training is focused on you to build apps for generative AI applications. So I'm going to be very brief in here whenever it comes to SageMaker Studio, but I wanted for you to get at least familiarized with some of the capabilities that are within SageMaker and the environment. And as I mentioned to you earlier, one of the things that I always recommend to people is to practice. Machine learning, cybersecurity, AI is all like math. The more that you practice, the better that you will become. Google Vertex AI is a unified machine learning platform that is offered by Google. Very similar, and in some cases even more powerful, and in some other cases, is complementary than the other cloud platforms that you saw from AWS. So it does have a lot of features, from data preparation and model training to the deployment and monitoring of foundation models that you can select from the model garden here. So if you navigate to model garden, you will see dozens and dozens of different types of foundation models, including from Anthropic, Meta, the thousands of models in Hugging Face, Mistral, and many others, right? So it is a unified platform. Instead of AWS that you had SageMaker and Bedrock, this one, all the tools are needed that are needed for machine learning. You can use them in this main dashboard in here. In my opinion, this simplifies a lot of the task whenever it comes to creating or fine-tuning models, right? So you can use features from AutoML that you can train models for tabular, image, text, or video without writing any code, similar to what you saw in SageMaker from AWS. For advanced users, also Vertex supports different custom training capabilities using popular machine learning frameworks like TensorFlow, PyTorch, and they have a capability for you to write your own training code, your fine-tuned hyperparameter configurations with capabilities within the environment here. One is actually called Vertex Visor. But we're gonna go over a few high-level interactions with generative AI, pipelines and implementations in here, since this training is focused on modern implementations of generative AI. So if I go back to the main dashboard here, you see that they have different types of implementations, including a Google Colab Enterprise offering, so basically running your own Jupyter notebooks, in a hosted environment, and so on. There are a lot of developer tools as well. So you have an SDK, so the Vertex AI SDK, which is a pretty comprehensive set of classes in Python that lets you automate a lot of the machine learning workflows and the generative AI implementations as well. You also can take advantage of Vertex AI Workbench, which is a Jupyter Notebook-based development environment that data scientists actually can use for their own entire workflow. And you can have information related to, or have capabilities that can allow you to store and manage training datasets, just like you're seeing here. Very, very simple, by creating new datasets, whether it's single label classification, multi-label, object detection for visual type of trainings, right? So image, tabular, text, and video as well. So if you navigate to the Workbench section here, basically this is what I was talking about, an environment that is based on a Jupyter Notebook deployment for your entire data science workflows. You can interact with Google Cloud Services and instantiate new environments like you're seeing here. You can put a new instance, attach NVIDIA GPUs, and so on. And then, of course, you have to pay attention to the costing here. But you can select from many different advanced options, including your environment, the type of the version of Jupyter Lab that you want to include, using custom containers if you want, and also including a specific metadata that you can add to your environment as well. So all these instance types are prepackaged with this Jupyter Lab environments and have a pre-installed suite of deep learning packages, including support for TensorFlow, PyTorch frameworks, and so on. You can use CPU only or GPU based instances as well. Of course, you have to pay attention to the cost if you want to experiment with some of them as well. So I'm going to cancel that for a second. Then I'm going to go back to the main dashboard here. Now, the next section that I want to cover is Vertex AI Studio, and specifically this one is the Google Cloud Console tool for rapidly prototyping and testing generative AI models. And this is how you can use models like, of course, Gemini from Google and many others for prompt engineering, as you're seeing here, from prompt management, fine-tuning a model for being more domain-specific, evaluating, and many other types of tasks that you can incorporate in here. Now, Vertex AI Studio supports certain third-party models that are offered on Google Vertex AI as a model as a service. This is actually a new concept that you are hearing nowadays called MaaS, so AI model as a service. In other words, for you to use third-party modules like Anthropic Claude models, Meta Llama models, and many others. The cool thing about this is that it allows you to either navigate through different prompt galleries and see in some examples of system prompt instructions and so on, and then you can change for your own implementation. So I've just selected a random one in there called Buzz Juice. It's the only energy drink for all organic ingredients. So you can actually get a little bit information here about the brand, the campaign goals. So this one is actually specifically for an advertising campaign. But at any rate, you can select different models. So in this case, of course, you have the Gemini models from Google, and you can also integrate other ones through third-party implementations, and you can navigate many of them in the Google model garden within the infrastructure here, right? So you have Anthropic, Meta models, Palm, and so on. Palm, of course, are the older models, and there are a lot of additional new capabilities. You can even include information for grounding or for retrieval augmented generation to then get source information from Google search, right, within your environment, right? And this is with very low code. As you can see, I'm just clicking on a few buttons, and if you click on get code, you basically get all the different elements on how to interact with the environment here in Python or the examples of in curl, right? So you have to, of course, enable the API for you to interact with the environment in here, but it simplifies the task significantly for you. You can also use multimodal. You can have images and additional, information that you can put for the model, for the AI implementation to take advantage of as context, additional context for your either agent or your chatbot. So under prompt management, let me actually clicking here to exit. You can create your own custom prompts, right? Either freeform, chat, translation, and so on. So if I click on chatting here, it takes you to the same page that we were earlier. And you can try even the multimodal element, which will allow you to use your camera and your microphone and so on. So I'm going to click on no for now. But yes, you actually have the ability to do vision, to take advantage of the translation capabilities that they have in here with multiple languages, and then also text to speech and speech to text recognition as well. You can upload different WAV files or record your voice and then have that as a multilingual automated, speech recognition environment, right? The other cool thing that you can do here is to fine tune different models. So you can select your environment in here. I'm in the East Coast, so I'm in Raleigh, North Carolina. So probably either South Carolina or Northern Virginia for me are the closest. And then from there, I can start creating a fine-tuned model, and I can name it, anything that I want, and select a base model. So I'm just leaving the default there of Gemini 1.5, and then you have different advanced options. I am not going to go over a lot of the elements of fine-tuning here, just showing you that you have the capabilities of doing fine-tuning in a pretty comprehensive manner in here. You can also associate this to a service account. I am going to skip this for a second just so I can demonstrate a few of the other elements in here for fine-tuning. And one of the crucial ones is, of course, your data sets. So here you can upload from a cloud storage or an existing file or cloud storage, whether it's something that you have in a Google store bucket or storage bucket, or just upload it from your computer here, right? And this has to be in JSON-L, which is the recommended, data set. And you can even view sample data sets, if you will. And in this case, they have tons and tons of them, whether it's in JSON-L file, just like you're seeing here. I just randomly click on an evaluation example, and you can edit metadata and so on. Of course, you can do this with your own datasets as well. So let me close that back. And of course, you can also enable model validation and upload the validation dataset as well, right? So if of course, I don't have any datasets right now, so I'm going to download a sample dataset. It's called SF Train Data Flow. So let me actually go and upload that. So the next step is actually to get that dataset to a bucket for then, of course, Vertex be able to access. So I'm going to do that. I have 2 buckets already in here selected, and then I can start tuning, right? And you see that I have now a tuning job called Omar Fine Tune Model 1 based on Gemini 1.5. The method is supervised and it's pending right now, and it's going to take a little while for it to instantiate. So while that is running, let me actually take you to another section here around model development, right? And this is whenever you're training a model from scratch. So if you click on train new model, you can take advantage of AutoML or even a custom, a little bit more advanced training environment. You have to be very familiarized with machine learning and data science concepts like hyperparameter counts and many others in here. So I am going to skip this one just because we're going to be focusing on how to deploy different generative AI applications using foundation models within the environment in here, or fine tuning, right? So if I go back to the fine tuning, now it is running. I can click on it, and you see that there's a fine tuning metrics that are being generated, and it will appear there whenever they're ready. Now, this of course will also cost a little bit of money, right? So be aware of that. But again, this is yet another platform that you can use generative AI models to create models from scratch, extremely powerful for fine tuning, allow you to automate a lot of the machine learning operations or MLOps operations within this environment as well. You can also get access to different embedding models, use retrieval augmented generation type of environment. So you deploy vector databases and so on. And of course, it will interact with the rest of the Google Cloud infrastructure for you to have different VMs, containers, and so on. So very, very powerful environment here in Google Vertex AI. Let's go over Microsoft Azure AI Foundry. This was formerly known as AI Studio, and Microsoft, keeps changing the name. I think that it already has changed the name twice or three times. But it's another unified cloud-based platform that is designed to help you develop, build, and customize different AI-based applications, right? So you can go over many different third-party models and deploy these. And of course, at the time of recording, I already had an inference endpoint already deployed. And don't worry, because I'm actually going to be deleting these after recording, but it includes the reference endpoint. So it actually automatically creates a URI for you. And then you have the ability to interact with OpenAI's models, as well as actually interacting with many, many other models, hundreds of them within their model catalog. Many of them that are in Hugging Face, that are open source, other ones that are proprietary, like the O1 models or the O models from OpenAI, the smaller models for like chat completions from Microsoft, including Phi, which is very portable, very powerful for being small models and very cost effective, that you can also run in OLAMA, right? So if we were covering OLAMA earlier in the course, you can absolutely run some of these models locally without the need of investing into a very comprehensive GPU infrastructure, or for that matter, any type of ASICs as well. So, this allows you to deploy these models with a couple of clicks. And there are over 1,800 models as of the time of recording, and this is actually continues to increase. You can have access to different playgrounds. So in other words, basically have a playground where you can experiment and iterate with different models and then customize them and customize a lot of your AI application components, including your system prompts and so on. And they have already a few previews of assistants, image playgrounds, real-time even audio playgrounds, some for healthcare and so on. So if I click on any of these, so let's say try speech playground, you have access to real-time transcription, back transcriptions, speech translation, and many others, right? So you can start interacting with many different models and, of course, different capabilities in here. So if I go back to the playground, the other cool thing about Azure AI Foundry is that it combines tools for data preparation, model fine-tuning, model testing, deployment, and monitoring in all these single platform. So for example, you can select from any of the predetermined models in here. I'm going to randomly select 5.3 4K for this section or for this demo. And you can select from a method for fine-tuning, whether it's a serverless API, so it allows you to fine-tune the model on a fully managed service that doesn't require for you to host or manage the infrastructure, or have a VM. In other words, manage compute. So I'm going to do manage compute for this example. And this allows you to customize the model with your own training data set, right? I can change this to OMAR 23 or OMAR model 23. At the end of the day, this project is called Demo Project 23. You can add a description. You can actually add specific tags and values. And this is something that I extremely recommend for you to organize and have a good asset inventory within your environment. But you can select the machine size, right? It gives you the cost per hour. So you can go as big as 96 core with 900 gigs of RAM and a whole bunch of storage in there, or just something very simple like the one that I'm selecting. You can select the training data, the validation data, task parameters, very similar to what you saw with the other platforms like Google Vertex AI and in AWS. Another cool feature from Microsoft here is the prompt flow feature, which is a development tool that is designed to streamline the entire development of the AI application by providing you a way to prototype and experiment and iterate your application with different types of course, prompts, and system prompts and so on. And it has an evaluation flow, a standard flow, and so on. Many different examples from gallery here, right? So if you want to do just a Q&A with your data, you can actually clone this example, and add it to your environment for you to actually create a new prompt, right? You can click on view details on any of these, and actually will tell you what are those examples of prompt flows implementations for you to then use, in this case, a chatbot interacting with your own data in a retrieval augmented generation implementation. Another powerful tool is tracing, which basically allows you to get an in-depth understanding of the execution process of your generative AI application. Basically provides a view of the execution flow of your application, and is really, really good for debugging your application and the complex implementations that you may have within your environment. So these are different environment features or different tools that I strongly recommend for you to become familiar with and I play as you experiment with your implementations. It actually allows you to visualize your quote-unquote traces, right? You can use tools that are built in here that to trace your application within the Azure AI Inference SDK, using that SDK to get more visibility into your applications, right? So this is another element that is really good for you to become familiar with. Another one is the evaluation of your AI application, right? So if you create a new evaluation, you have to deploy a specific model. Let me actually close that in there. And I already had a deployment. It was GPT-4o Mini, that I did a while back in here. But you can see that you can do a lot of different tests for your applications, and including generating some content and including the automatic evaluation using AI to measure how well your model and your implementation is producing good responses and so on. They also have ability for you to do monitoring and guardrails, to implement guardrails on content filters and block lists that you can implement within the environment as well. So if you want to create a specific block list related to a custom policy that is pertinent to you or to your organization, you can absolutely do that in here as well. Another thing that I want to highlight is that Azure AI Foundry has a section here called Code, and these are example templates and tutorials for coding AI within your environment, right? So coding your AI application. And they even have examples of knowledge retrievals of RAG, right? And you can even open these in GitHub. So I'm going to open it in a different tab in here. Or you can also see tutorials that they have related to each of the elements of not only these templates and these examples, but also across all Azure AI Foundry. So they have a really good documentation and a lot of tutorials and sample code in GitHub, just like you see in here. This is a test application called Contoso Chat, and it's a retail RAG copilot that is being used or that is deployed with Azure AI Studio and PromptAI. They still have their old name here, AI Studio instead of Foundry, but you get the point. Same thing here. And this is basically the application, the fictitious application that they have in here with basically a copilot or an assistant using retrieval augmented generation. So as you can see, these environments can accelerate your experimentation and your deployments of AI applications very, very, very fast, building on top of cloud platforms like Azure AI Foundry. And of course, we already cover the platforms in AWS and Google Cloud. In the next section, we're going to discuss a few things around cost management and security. Cloud-based AI platforms like the ones that we just discussed, Azure AI Foundry, which is what you're seeing in front of your screen, Google Vertex AI, AWS Bedrock, SageMaker, definitely they have become essential tools for you to leverage AI at scale. However, managing cost and ensuring robust security are two critical challenges whenever you're using these platforms. So here, what I would like to do is explore a few tips around cost management strategies and also security best practices for these leading AI cloud environments, and then to help you, of course, optimize your investment and, of course, protect your wallet a little bit, right? So I was making the joke that from the moment that you start experimenting in here, you start clicking on a few things, new machines are being instantiated, new S3 buckets in the case of Azure or AWS rather, or compute nodes or endpoints are being instantiated, and then in some cases you may leave them running. So you have to be paying attention to that. However, many of these platforms, including Azure AI Foundry, they provide a very comprehensive set of tools for cost monitoring and optimization. The challenge is that there are a lot of tools that people don't know about, right? But you have things like the cost planning, and as a matter of fact, they have a really good calculator, so an Azure pricing calculator to estimate cost before you actually even deploy things, right? So Azure AI Foundry is definitely composed of multiple Azure services. So again, compute, storage, and many other ones. So it's important to account for all the components whenever you're planning these budgets, right? And then you also have quotas. So you can configure specific quotas within the environment to then prevent being able to get overcharged for things that perhaps you're not even running or using, or they're running rather. So you're not using them, but they're actually, you kept them running within the environment. All the AI models that are deployed by the Azure Marketplace or the model garden in Google and so on, they operate on a pay-as-you-go basis. So that allows you to a little bit more granular monitoring of consumption, and then for you to analyze the associated cost. So again, Vertex AI also offers very flexible billing options, detailed to cost tracking, granular billing, labels for cost attribution, so you can assign labels to custom jobs or pipelines, which then they can be used to group the cost in billing reports, right? So again, if you are part of an enterprise, these are things, best practices that perhaps you're already following. But if you're getting started with some of these platforms, you have to pay attention to all these real-time cost control and optimization tools that are at your disposal. Now let's shift gears into security. There is a website that I helped create called aisecurity.cisco.com, which will redirect you to many different fundamentals, white papers, and guidance around security, including how to secure vector databases in the case of a retrieval augmented generation environment, what are AI security vulnerabilities, and the one that I want to highlight bring your attention to is the AI training environment security. And this is a paper that I co-author. Actually, in fact, most of these are actually have the honor to co-author with other colleagues. But this one specifically goes over the security best practice and considerations in cloud-based platforms, and specifically in the three that we have been covering here. So if I shift your attention to the paper and specifically to this section here, we have a section related to the cloud data protection recommendations, and of course, very basic but very important best practices like using multi-factor authentication everywhere, log API user activity, protecting your data, using, of course, secure communications for your cloud resources, and in many cases, actually using strong crypto implementations. However, we also have linked different guidance documents from Bedrock, SageMaker, Google Vertex, and also from Foundry later in here. But I already have this open in different tabs for your reference. I'm not going to go and read this for you, but I strongly recommend for you to become familiarized with these security best practices. And as a matter of fact, just generic best practices for the cloud. And in some cases, you can even use Amazon Q to learn about the different security best practices within the environment as well. So leveraging the power of AI in some of these platforms, right? They also have examples on how to protect your data in Amazon SageMaker, and also Google Cloud has a lot of security controls for generative AI, and they even have a section here that basically compares all the different functionalities and the different controls available for generative AI features across their ecosystem. So definitely I recommend for you to read these security best practices, and specifically since these platforms, all of the ones that I mentioned, Vertex, SageMaker, AWS Bedrock, and AI Foundry from Microsoft, they are changing by the minute. There are new features that perhaps are introducing new security challenges, and then they also introduce new security best practices and configurations that you should pay attention to on an ongoing basis. You can also deploy OLAMA in the cloud, like in AWS, in Google Cloud, and so on. You can use things like Terraform to automate that deployment. But you may ask, why would you like to run OLAMA in the cloud if you can run it in a laptop, or if you can run it in a PC with a good GPU? Well, in some cases, you may not have enough compute to run some specific models. Let's say a large parameter count model. Let's say something that is running 80 billion parameters or 128 billion parameters and so on, right? So those, you may not have the compute time or the compute power in your home lab. So in that case, you may deploy it in your private instance, let's say an EC2 instance in AWS, and then run that from there. However, whenever you're learning, it is a good thing that you can incorporate these proven technologies like Terraform and so on, and then deploy things like OLAMA with a specific model, and then going over and run other tools on top of it, like Open Web UI, which we covered earlier in the course. So I have a write-up about that. I'm not going to go into a lot of details because the write-up actually goes over the specifics, but this is a repository that includes a lot of different Terraform scripts and all your configuration variables and so on for you to deploy the architecture of running OLAMA and Open Web UI in the cloud. So the deployment architecture looks like this, and this is actually in the GitHub repository that I have linked in there, where you have different EC2 instances, a private and a public subnet, and then you have the ability to run Open Web UI in an ECS Fargate implementation. And then, of course, you can take advantage of Route 53 for domain tasks, or DNS tasks and so on. Now, what I did in here is actually I provided the different elements of the Terraform scripts, including the LLM models, the config variables, the Open Web UI settings, which is a separate section within that GitHub repository, and then of course all the custom domains and any type of SSL certificates that you may need for securing the API gateway, and including the application load balancer that is instantiated for this environment, specifically for Open Web UI. And then to initialize the Terraform platform, there's a typical Terraform init, and then Terraform apply into that. And I just noticed that I have a little typo in there because it's supposed to be another line in there. But at any rate, all this is in the repository, and I would like to actually at least share this with you because there are many different ways that you can deploy your lab, whether it's on-premise or in the cloud or in a hybrid mode as well. Welcome to Lesson 3, Integrating and Leveraging AI Environments. In this lesson, we will go over hybrid AI labs, in other words, combining home labs and cloud resources. We will talk about synchronizing data and projects and leveraging the strengths of both environments. We'll run open source models or open weight models available on Hugging Face and explore tools like LangChain, Llama Index, embedding models, vector databases, and many others. One approach that you can take is using a hybrid AI lab, which is basically combining on-premises or your home-based lab with infrastructure that is within cloud-based resources, right? So this hybrid mode will basically offer the best of both worlds. Basically, you have the control and security on-premise and, of course, the scalability and flexibility of cloud platforms. The reality of today's world is that most organizations are using cloud platforms, and they're also exploring how to bring back some of the cloud capabilities on-premise because of the cost of AI. So the more that you're familiar with these implementations, the better for you. One of the beauties of hybrid AI labs is that they integrate the on-premise infrastructure that you have, your local servers, your infrastructure with the cloud-based resources from AWS, Google Cloud, and Azure that we were just discussing earlier in the course. In the next few segments, we're going to talk about synchronizing data and projects between your environment and in the cloud, leveraging the strengths of both environments, running open source models that are available in Hugging Face, and we started to actually do that earlier in the previous lesson. But we're going to go over a little bit more in detail about different model gardens, model playgrounds that you have within cloud-based environments, and use those models that are available, the open weight models that are available in Hugging Face. You're also going to be learning about how to use Hugging Face models in Ollama as well. Synchronizing data between projects home or in the cloud can be pretty complex in some cases, and in some cases it can be pretty simple, right? Depending on what you're trying to do and depending on what you're exploring and experimenting with. So in some cases, if you want to replicate a real world enterprise level workflow, then you need to explore different tools that are provided by some of these cloud providers, like AWS DataSync or BigQuery, right, to schedule queries automatically in a specific period, and so on. However, if you're doing something simple as basically playing with Ollama and a couple of open weight or open source models out there, and you want to take advantage of the low code or no code infrastructure by some of these providers, then you basically leverage APIs to enable seamlessly data exchange between systems, and then provide some flexibility for integrating cloud services with your on-premise solution. However, in some cases, most of these labs are done in isolation. So in other words, you're actually playing with some of the models, some of the libraries like LangChain, Llama Index, and many of the ones that I'm going to be sharing with you, on premise, with something like Ollama running a Meta, a Microsoft, small language model like Phi or Llama, and so on. Or in some cases, you're actually doing everything in the cloud and just have your development, environment locally in your lab, right? So in on premise. So it all depends on the scenario in here. But there are a few best practices for data synchronization, and specifically if you're now going over some advanced labs, like for fine tuning, for training a model from scratch, and so on. You need to, whenever you're doing data synchronization, you need to maintain data integrity. So you have to use some type of validation process to ensure consistency across all your systems, right? You can implement distributed transaction management protocols like two-phase commits and so on, go to that level of detail, or have something very simple as just a hash verification whenever you're transferring files. Some of the cloud providers allow you to develop automated mechanisms to handle conflicts whenever you have even multiple users edit some data, right? For example, prioritize changes based on timestamps or user roles, etc. But if you're just doing a very basic lab, you probably don't have to worry about a lot of problems with data synchronization between many users, since you're probably going to be the only user. However, if you want to take it to the next level, as I mentioned to you, some of these providers like AWS, they provide solutions like DataSync, AWS DataSync, which is an online data movement and discovery service that simplifies and accelerates data migrations in AWS, as well as moving data to and from on-premise storage, edge locations, and even other cloud providers. If you have something in Google Cloud and you want to transfer it to AWS or vice versa, these types of solutions allow you to actually do that. But since this course is tailored for people that are just building simple apps, whether at home or in the cloud, I'm going to skip a lot of the details related to these tools like DataSync and some other providers in this course. In the next section, we're going to talk about how to leverage the strengths from both environments on-premise and also in the cloud. So by now, you know that combining the capabilities of your home lab with cloud-based solutions definitely will offer you a powerful strategy for innovation, for upskilling yourself, experimenting, flexibility, and also cost efficiency. Right? Each environment has its unique strengths that whenever you leverage them together, you can create a seamless ecosystem for AI development and of course for experimentation and for you to learn about the technologies. It is inevitable that you will have to interact sooner or later with a cloud provider, whether it's interacting with a model directly from a provider like Anthropic or OpenAI, or using the cloud environments that we covered earlier, like Google Cloud, in the case of Google Vertex AI, Bedrock in AWS, or Azure Foundry, right? So now the cool thing about the home lab is, of course, you can run tools like Olama that we have been mentioning here really, really pervasively, right? Because it makes it easier than ever to run a language model at home on your personal machine on a system that doesn't require hundreds of CPUs or GPUs rather to run some of these foundation models. You can actually run Olama and simplify the process of running open source LLMs locally or open weight models locally, like Llama, Vicuña, etc. Right? So you can customize them as well, even using the model file implementation within Olama. And we will go over some of the technical details on that later. However, some of the advantages, of course, of home labs is cost control. There's no recurring cost for cloud compute resources. Also, the offline capability, so operating without an internet connection, ensuring uninterrupted access to the AI models, since they're actually running at home. And of course, full autonomy, so complete control over model configurations and data handling. Now, the strengths of cloud AI labs definitely are obvious, right? So cloud platforms like AWS, Google Cloud, Microsoft Azure, they were not invented yesterday. They are very scalable, allow you to have on-demand access to high-performance GPUs and TPUs for training complex models. And then providers like SageMaker, Google Vertex, and Azure, they offer pre-trained models for tasks like image recognitions and very domain-specific things like translation or vision, speech, language processing, many other things that you can leverage out of the box from those environments as well. And specifically, not only with generative AI, but with traditional machine learning as well. So some of the advantages of the clouds, of course, is the compute power, the ease of integration. A lot of these, of course, they provide from cloud services like storage, like S3 buckets, or analytics tools, and things that you can incorporate within your AI deployment. And specifically nowadays, whenever you're trying to create agentic implementations, they also provide a low-code or no-code environment for you to start integrating your data and your workflows and your tools and allow them to operate on that data, of course, and create cyclical workflows for agentic implementations. So here are some recommendations. If you're doing just research and development, if you want to just experiment with open source LLM locally, running Olama, leveraging your ecosystem at home, I think that's the best use case for you to get familiarized with that. Or even if you want to get familiarized with vector databases like Chroma, pgvector, many open source vector databases that you can run on premise with your own data and research and development of your applications, definitely that's actually something that you can really easily run at home. Now, if you want to deploy something that eventually will be like a customer-facing chatbot or using quantized local models for privacy while relying on cloud services for advanced analytics, you can absolutely do that, right? You can combine local inferences capabilities from a home lab with cloud-based monitoring systems to enable real-time decision-making in things like IoT implementations, right? What we call edge computing, and nowadays we call AI edge computing. So again, depending on the ecosystem, there's a lot of pros and cons on each of those deployments. In the next section, we're going to go over how to run open source or open weight models available on Hugging Face. Hugging Face has become definitely the go-to place for the AI and machine learning community because it basically offers a very vast ecosystem of open weight and open source models. It also includes datasets, resources, papers, tutorials, many, many different things. But definitely a lot of people go there to take advantage of AI models that are open source and open weights that you can build a lab in your home, or you can, of course, use them in the cloud as well. We went over many different implementations in cloud providers, including Bedrock, SageMaker, Vertex AI, Azure AI Foundry. All of them have access to open weight models that are available in Hugging Face. You can load pre-trained models from scratch by actually using the transformers and the Torch and TensorFlow libraries and so on, or use things that you learn like Olama. Running a model from Hugging Face in Olama is extremely simple. You can follow these steps, right? So you already know that Olama is a tool that is designed to simplify running and managing large language models or small language models locally, and it supports models in the GOF format. And basically, GOF stands for GPT Generated Unified Format. It's a file format that is specialized for storing large language models or small language models optimized for fast loading and efficient inference, right? It's definitely something that was created for the popular Llama CPP, which at the end of the day is one of the foundations for open weight models out there. It became the inference framework for that. So one of the things is that you combine model parameters, so weights, tokenize their vocabulary, configuration attributes, metadata into a single file, and it simplifies the management and the deployment of these models. So you can use any of the Gov-based models created by the community and available in Hugging Face directly in Ollama. And to do so, the command is really simple. Basically, it's an Ollama run, and you put the URL of the Gov-compatible model in Hugging Face, just like you're seeing in the screen, and that's it. You can actually run it locally in your system with no configuration of parameters, no configurations of any additional libraries, and so on. And it cannot get any simpler than this. So this is how to run, or one of the examples of how to run a local model from Hugging Face using Ollama. Now, as I mentioned earlier in the course, there are different alternatives to Ollama for running models locally. Several excellent tools and frameworks that definitely you can take advantage of. Another tool is LLM Studio, and LLM Studio is also a very powerful ecosystem where you can run LLMs in your laptop or your desktop machines, chat with your local documents. So in other words, basically do a retrieval augmented generation, and even use models in-app through a GUI or an OpenAI compatible local server, which is pretty nifty in there. So LLM Studio is, or LM Studio is another very popular tool out there. The one that we covered earlier was Local AI, which is another alternative to Ollama. You can run it also in a Docker container, just like you see in the screen here. So different alternatives for running local models. But one of the most popular definitely in the community is Ollama, and it's because of the ease of use, tons of integrations and development by the community, and the support of many different models that you can run in different environments. Now we're diving into LangChain, which is a very powerful framework that simplifies the process of building applications powered by LLMs and SLMs, and of course, any AI models. Now, this ecosystem or this framework called LangChain is extremely popular because it streamlines every single stage of the development lifecycle for AI applications. Whether you're creating some sandbox environment at home and you want to optimize some task at your home and interact with vector databases, interact with different AI models, all the way to creating very sophisticated enterprise-grade applications. LangChain integrates seamlessly with dozens of providers and technologies, making it versatile and robust for a wide range of use cases. At its core, basically, LangChain has a standard interface for working with LLMs, including OpenAI, Anthropic, open source models in Hugging Face, and so on, and even integrating with Ollama. You can use LangChain very easily with Ollama as well. Now, in the screen, you're seeing the LangChain architecture, where you have the library in the bottom. It also provides tools like LangGraph, which helps build stateful agents with advanced features like streaming and human-in-the-loop support, and many others. There are other components like Langsmith that allows you to monitor and evaluate your applications for continuous improvement. And throughout this course, we'll explore how to leverage LangChain, open source components, integrations, and orchestration frameworks to build intelligent systems, AI applications that are not only functional, right, but they're production ready, whether, again, you're just experimenting at home or deploying something at work as well. In my GitHub repository, I have dozens of resources related to LangChain. I have many different examples on how to use LangChain with vector databases, how to create embeddings, how to do cyclical workflows, and tutorials that are available publicly and very openly, and also a lot of Jupyter notebooks that you can take advantage of for experimenting and deploying your AI application. Later in the course, you're going to see more examples of how to use LangChain with different environments, including vector databases, embedding models, and other frameworks. You're also going to be learning about Langsmith and LangGraph as well. In the next segment, we're going to talk about Llama Index, which is an alternative to LangChain. Now we're going to explore Llama Index, which is another framework that is designed to enhance the capabilities of large language models or LLMs by connecting them to custom and private data sources. In other words, actually deploying retrieval augmented generation and other implementations like chatbots, assistants, and so on. It is an alternative to LangChain as well, because it acts as a bridge between the LLMs and a diverse data formats such as PDF databases, APIs, and more, and allows you to do a lot of function calling, tool calling, and so on for different automated cyclical workflows. At its core, Llama Index provides tools for data ingestion, for indexing, for querying. In other words, all the different components of a retrieval augmented generation pipeline. It allows you to create chatbots and also to extract insights from your documents and also to evaluate your implementation. So definitely, this is another alternative. We're not going to go into a lot of details about Llama Index in this course. We're going to concentrate a little bit more with LangChain later in the course with a few examples because of popularity. So both of them are pretty popular in the community. I would say that probably LangChain is just a little bit more popular, and just because of time and because of the ease of use, I'm going to concentrate a few examples later in the course using LangChain. But again, there's a lot of documentation for Llama Index, a lot of tutorials, a lot of support from the community, and so on. So it's another alternative for an orchestration library, so you can integrate vector databases, embedding models, and your LLMs and SLMs as well. So let's go over what are embedding models, and simply put, they're tools, or of course, machine learning models that transform complex data like text, images, or audio into numerical representations called vector embeddings. And these vectors capture the meaning or the features of the data in a way that actually makes it easier for AI models to understand and process. So think about embeddings as maps where similar items are actually placed closer together, helping AI systems to actually find relationships and patterns between, again, whether it's an image, an audio file, text, and so on. So what you're seeing on the screen is basically a tool called the Embedding Projector by the TensorFlow community. And it's a really cool visualization of different words. You're actually seeing a whole bunch of bubbles in the screen, but if I hover over, you see that actually a lot of words appear in the screen. So I just randomly selected that word nutrition. So I'm going to click on it. And now what you're seeing is a representation of quote unquote the neighbors. So other words that are related to nutrition, whether it's health, metabolism, food, dietary, and so on. And you're actually seeing some points. And these are the nearest points in the original space. In this case, we're actually doing cosine similarity search or distance. And you also can do Euclidean. For the purpose of this course, we're not going to go into all the details of cosine versus Euclidean, but these are different techniques that have been used for quite some time, whether it's in search engines, recommendation systems, image recognition, sentiment analysis, and nowadays, of course, with large language models and modern implementations. Now, the magic in here lies on how embeddings simplify the high dimensional data into a lower dimensional vector while you're actually trying to preserve the meaning of the semantic meaning of those relationships. So again, in this case, the word nutrition and the relationship with it with other other words. So this is what actually the AI models also use to predict what is the next token in either in an image, an audio file, or of course in text. Now there are a lot of examples of very popular embedding models and their applications. What you're seeing here is something very simplistic. As a matter of fact, I just left the default, which is Word2Vec. In this case, it's a 10K version of it. You can actually pull down from the menu and you see other ones in here. Word2Vec is a model that learns word embeddings based on the context using techniques like skipgram and continuous bang and a whole bunch of other terms that we're not going to actually cover here in the course for brevity. However, there are many others. There's the global vectors of word representations or GLOVE. There's also contextualized embedding models like BERT, so bidirectional encoder representations for transformers, right? So these are a little bit more modern implementations that provides or produces context-aware embeddings by considering the words before and after a target word. So similar techniques are used by modern multimodal embedding models, including the OpenAI models, the Google models, Cohere. There are many companies that actually produce embedding models. Now, there are a lot of embedding models in Hugging Face that are open weights that you can use for different operations, whether it's for clustering, for overall big stacks mining, classification, pair classification, re-ranking. And what this is doing is actually giving you a leaderboard based on an implementation called the Massive Text Embeddings Benchmark, or MTEB. And if you're interested to learning more about the Massive Text Embeddings Benchmark, or MTEB, feel free to actually visit and download this academic paper that I'm showing here in the screen. I also helped create a paper about selecting embedding models, and that can be accessed at the URL aisecurity.cisco.com. And if you scroll down, you're going to see different papers. One is around securing vector databases, and we're going to go over vector databases later in the course. And then there are some best practices around AI training environment security, as well as how to select embedding models. So if you click on that, we go over a lot of the details around the different terms of embedding models, examples of embedding models. This one is actually one from Cohere, and let me make this a little bit bigger here for you. And in there, actually, I have several examples on how I use embedding models for creating different types of applications, but specifically a lot of best practices on how vector embeddings work and how to select them, and specifically selecting embedding models with security in mind. And if you scroll down in this paper, I have tons and tons of examples, again, of different embedding model representations, and then some best practices around selecting and securing embedding models as well. So this is here for your reference, and you can access all these papers in the website aisecurity.cisco.com. Let's go over what are vector databases. Vector databases are so popular nowadays in many modern AI applications, especially whenever you are leveraging retrieval augmented generation, or RAG, and also in agentic implementations. But what are vector databases? At its core, vector databases or a vector database is a specialized system, a specialized database that is designed to store and manage data in the form of vector embeddings. And you already learned that vector embeddings are numerical representations of data like text, images, or audio. And these vectors capture the semantic meaning of the data, then enabling you to do similarity search or semantic search that go beyond traditional keyword matching. So this makes vector databases very powerful for tasks requiring context and relevance to be given to an AI model to then, of course, give you a better answer. Now, there are a whole bunch of different popular vector databases that are widely used in AI applications, agentic systems, and RAG systems. One of them is called Chroma. It's an open source vector database that is extremely easy to deploy, especially with orchestrations libraries like LangChain and LlamaIndex. Another one is the Facebook AI Similarity Search, or FIAS, which is a library rather than a full database, and is extremely popular for research setups and sandboxes, and especially since it allows you to leverage GPU accelerated similarity search. Another one that is also open source and very popular is called Weaviate, and it's an open source semantic search engine that definitely excels at handling unstructured data like text and images. And it also includes built-in modules for hybrid search capabilities, which are more advanced semantic search capabilities within vector databases. Milvus is another open source database that is designed for high performance similarity search. It supports a very large-scale AI application integration with tools like TensorFlow and PyTorch and many others. And of course, you can also interact with it with the orchestration libraries like LangChain, LlamaIndex, and many others. Now, there are a few that are commercial. One that is extremely popular is the Mongo Atlas or the MongoDB Atlas vector search. Many companies use this vector database capability because it's extremely fast, it can scale significantly, and it's also driven by a cloud environment that is maintained by the MongoDB folks. So definitely that's probably one of the most popular ones in the commercial space. Another one is actually called Pinecone, and it's also a fully managed cloud-based solution, and it also can scale and has a lot of capabilities, ideals for applications requiring real-time retrieval. Now, in the screen here, you're seeing basically some code that I have in a GitHub repository for another training called Retrieval Augmented Generation for Cybersecurity. And I have tons and tons of examples in this GitHub repository, but specifically, I have a part here that is related to Retrieval Augmented Generation. And in this case, I'm creating vector embeddings using the OpenAI embeddings models, and then putting those embeddings from a file into a vector database. And in this case, the vector database is Chroma. I'm going to continue to add a lot of examples to this GitHub repository and also to the other repository that you learned about before in the training or earlier in the training. And again, technology is advancing so fast that what I do in order for me to scale is to put a lot of this information within the resources that I'm giving you here, which are living documents. These GitHub repositories are updated almost on a weekly basis, if not in a daily basis in some cases. So definitely take advantage of these examples, and especially as you experiment and build labs and sandboxes, whether it's in the cloud or in an on-premise environment. Welcome to Lesson 4, Introducing Langsmith, LangGraph, Fine-Tuning, and Edge AI. In this lesson, we will discuss how to leverage Langsmith and LangGraph, and we will go over examples of using fine-tuning frameworks and tools like Onslaught. We will briefly discuss high-performance computing and Edge AI, which is basically running AI models on edge devices. Let's get started. Now we're going to explore two powerful frameworks from the LangChain ecosystem. One is called Langsmith, and the other one is called LangGraph. Now, of course, this training is around building a lab, whether it's at home or in the cloud. These are applications that are optional. You don't have to actually have them in a lab environment, but these are very useful out there. Now, Langsmith is a comprehensive platform and is commercial, so you do have to pay for it. So if you're just getting started and you just want to do some evaluations and so on, you need to get the API key from LangChain in order to use this platform. But at the end of the day, it focuses on monitoring, debugging, and optimizing AI applications that are powered by the LangChain ecosystem and, of course, by large language models. So it provides you with a full visibility into the application that you're trying to create and your workflows, right? It has the ability for you to trace the prompts and the interactions between chatbots, agents, and so on with the LLM. So you can gain insights into every step of the AI pipeline from input to output. So in other words, from the prompt to the actual inference, so the output of the LLM. And you can also evaluate and compare different models, prompts, architectures, evaluate your system prompts, evaluate your retrieval augmented generation, deployments, and so on. And you can quickly iterate on prompts or configurations to achieve more accurate results. So that is actually Langsmith. Again, just an optional thing that you can play with. although you do have to pay attention to the cost. Now, LangGraph, that is another platform that is really comprehensive, that basically takes a little bit different approach than traditional AI applications by focusing on building stateful multi-agent workflows. So unlike traditional pipelines, basically LangGraph is trying to use, or is using, graph-based structures where agents act as nodes and their interactions form the edges of that node, or that graph, if you will. Right. So this LangGraph framework definitely excel at a few things. One is orchestrating complex workflows, so creating workflows with loops, branching logic, and conditional steps. Another one is state management, so maintain persistent states across interaction between your agentic implementations and, of course, your LLMs. And then it also enables memory and context awareness in different AI applications. And then you can also coordinate multiple agents. So nowadays we're living in a world where it's not about one AI agent, but it's a network of agents actually working together. So LangGraph can be used to build these sophisticated agent or agentic implementations, and that also handle multi-turn conversations while maintaining context to create an autonomous ecosystem to then collaborate on and produce the output for helping in complex tasks. Like, for example, you can do this for financial analysis, customer support, for healthcare. I mean, pretty much everything out there. So at the end of the day, this is something that you can deploy in the cloud. So there's a LangGraph cloud that is a commercial deployment, and you can also implement it locally. So you can download LangGraph Studio, which allows you to iterate through these implementations, and of course, create your agentic AI applications. So for building something in a lab, I would recommend just to download LangGraph Studio first, become familiar with it, and then try to incorporate it within your environment. Again, the LangGraph cloud is a commercial entity, so you have to pay for that. So start with LangGraph Studio in your PC, and then try to build, these sophisticated deployments and AI implementations. In this section, we're going to talk about fine-tuning AI models and what can you do in a lab environment. You already learned that many of the cloud platforms allow you to fine-tune models, and but we haven't even defined, what that is, or explain how you can fine-tune models. Yes, even at home, especially with small language models like 5.3, 5.4, the plethora of them that they actually assist nowadays. But fine-tuning involves taking a pre-trained model and then adapting it to a specific domain or a task by training it further, and of course messing with the weights. And of course you need data in order for you to do that. For instance, you can fine-tune a model to be very domain specific, let's say cybersecurity, to be really good on threat intelligence reports or vulnerability assessment and so on, that they can help identify security risk, analyze logs, or suggest mitigation strategies for cybersecurity attacks. Now, what you're seeing in front of your screen is basically a high-level diagram of the fine-tuning process where you actually can select a domain. Again, I just mentioned cybersecurity. So after you select the domain, you incorporate a knowledge base. So in other words, your data sets, and then you select a specific task. In this case, of course, cybersecurity task. It can be also text summarization, creating code for specific environments and so on. And then, of course, you have the task-oriented results, and you start evaluating the output of the model to then either adjust some of the parameters and hyperparameters in order for the model to excel at a specific domain or at a specific task. There are a few different tools, especially tools that are open source, that allow you to simplify the process of fine-tuning. So I list a few examples of those, and of course, including the fine-tuning process as you see in there. I'm not going to go into the detail. However, if you keep scrolling down in the page, I have a few fine-tuning frameworks for language models, and specifically, I highlight 3 that are very popular. One that is called Onsloth, another one Axosloth, and then TorchTune as well. And hopefully I'm pronouncing those correctly. But by far, one of the most popular is Onsloth. It actually reduces RAM requirements and accelerates the fine-tuning process and supports different quantization techniques and different quantized models and quantization techniques like LoRa or QLoRa. And guess what? I also have another article in the same website, becomingahacker.org, about LoRa and QLoRa and quantization techniques and so on, but I'm not going to go into that in here. So as I mentioned, Onsloth is open source. It's available at the GitHub repository that you see in the screen. And you can also access an example Collab notebook that I do have a link in that write-up. And then, of course, that will bring you to this collaboration notebook, so Google Colab notebook. And in this case, it's an example of fine-tuning an older version of Llama, so Llama 3.1. And in this case, it can be applied to any other of the newer models, right? So you have examples here with Mistral, with Phi, and also there are older models, but you get the point. Basically, this can be applied and can be used with many of the models that are available in Hugging Face. And it goes over pretty much the whole process from data preparation to training the model and evaluating the model as well. So definitely take advantage of that example. And as a matter of fact, even in the same write-up, I do have a couple of links to a few tutorials that also assist on the internet. Now, Axolot is another tool that is designed to provide this flexible environment for fine tuning, and it's also open source. And then the other one is a PyTorch native library called TorchTune. So there are, of course, a lot of cloud providers, and we covered that already. So Google Cloud, AWS, Azure, they have Vertex AI on where you can fine tune environments. SageMaker is another one, of course, from AWS and so on. So you learn about those platforms. I'm not going to cover them here again, but I wanted to give you some pointers of open source tools, especially powerful tools like Onslaught, TorchTune, and the rest. Even though this course is about building a lab, I would like to share with you at least a high-level overview of high-performance computing, what NVIDIA calls accelerated computing solutions, and also edge AI. So high-performance computing, or HPC, is basically the use of powerful computing systems, including GPUs, DPUs, of course, the integration of CPUs as well. Also, the implementation of ASICs, which of course is not represented here because NVIDIA, focuses on GPUs. But there are other companies like Grok, and this is not the AI model from X. It's actually a compute platform that specifically they design chips and create chips or ASICs that are tailored for AI implementations and AI models. So one of the differences between high-performance computing and traditional computing is that unlike standard computers, high computing or high-performance computing systems leverage parallel processing at a really, really large scale. So this one is not only for AI, it has been used for simulating weather patterns, designing safer cars through many simulations, and nowadays, of course, using AI. And tons and tons of industries actually use this, including manufacturing, healthcare, of course, all the providers of AI models or foundation models, including the OpenAIs, Anthropics, Googles of the world. Now, the other concept that I would like to introduce in here is edge AI and edge computing. And basically, edge AI combines artificial intelligence with edge computing to enable models to run directly on local devices. And again, we have been discussing that throughout the course here today. And they can also run at the network edge. So in other words, run in embedded devices like routers, like a Cisco router and so on, or even IoT implementations. So the other concept of this is running AI in autonomous vehicles, in robots, and many other implementations as well, and then bring in the physical AI applications. So in other words, be able to do a lot of the calculations in devices that can interact with humans, not only an autonomous vehicle, but as I mentioned to you, in a robotic type of implementation. So as we look to the future, the convergence of traditional computing, high-performance computing, accelerated computing, and edge AI will definitely continue to drive a lot of innovation, and this will unlock a lot of new opportunities in the field of autonomous systems, personalized medicine, and of course, assistance in the form of robotic assistance, not only just a chatbot. And together, these technologies will definitely empower you to operate smarter and improve lives, hopefully. And we need to tackle the security challenges of that. And of course, I dedicated my whole life to cybersecurity, so I have to always keep cybersecurity and security of these systems in mind. But the future of computing is one where intelligence will be everywhere, whether it's in the cloud, at the edge, in your car, in your IoT systems, or probably very soon in a robot in your house, helping you with some of the mundane tasks, and perhaps listening to other courses like this one while a robot is actually performing the boring elements of cleaning and a lot of chores around the house. Congratulations on completing this course. You have taken an incredible steps towards mastering the art of building and optimizing AI environments. From exploring cloud platforms like Microsoft Azure AI Studio, AWS Bedrock, SageMaker, Google Vertex AI, to integrating hybrid labs and diving into advanced topics. Now you have the tools and the confidence to innovate in the AI space. Remember that AI and all technologies are constantly changing on a daily basis. So you have to stay curious, keep experimenting, a lot of hands-on exercises, and continue to refine your AI lab to meet new challenges and opportunities in the industry. Thank you for joining me on this journey, and I look forward to seeing you and the amazing things that you will create with your AI lab. Good luck and happy innovating.